There we go. So DNS we kind of previously discussed, and we're going to discuss it a little more this morning. Okay. It translates fully qualified domain name to an IP address. Okay. It also does some pretty cool stuff like host aliasing, meaning that, a really good example of host aliasing is if you open up a command window and you go to Google. If I want to go out here and go ping www.google, well, look, there's an IP address. Looks like it worked. Well, what happens if I do an NS lookup 142.251.33.36? By the way, that NS lookup command, everyone should know. Okay. If I have somebody that's supposed to come to work for me, that's supposed to know computers, no matter what the career is, and they don't know what NS lookup is, honestly, I'm moving to somebody else. Write these commands in your handy dandy notebook. Memorize them. Write them 10 times each if you have to. These are the important commands. So I did an NS lookup. What does that do? It queries DNS. It's querying my DNS. This is called a reverse lookup because you're looking up by IP versus by a name. But look at this. Does that look like www.google.com? It doesn't. It looks like, to me, it's a server in Dallas, Fort Worth, and DNS has the ability to alias the www name. And it also has the ability to do load distribution. Okay. I can also try NS lookup, www.google.com. And there we go. It's giving me a, address that I've got. And it is also giving me a, IPv6 address. Notice that it says non-authoritative answer. Let's get some questions and get our brains firing this morning, because mine definitely needs to be firing. Notice, by the way, the DNS server right at the top, whenever you do an NS lookup, it tells you what DNS server it talked to. Well, this is my wireless router, and my wireless router is really forwarding DNS requests to my ISP. But let me ask you this question here. What does this non-authoritative answer mean? What does non-authoritative mean? Answer in the chat session. Okay, what does non-authoritative mean? Seth says the info's coming from the DNS, but not Google. The answer didn't come from Google's DNS server. Easton says. James says the same thing. Says coming from DNS. So let's see. Anybody else? I got 15 folks this morning. Anybody else want to, what is non-authoritative answer? Yeah, it didn't come from Google's DNS servers. So if I've got Shot, it doesn't necessarily, two of you said coming from DNS. It doesn't mean it's coming from DNS. Rather, it means it's not coming from Google's DNS servers. Okay. Now, why? Why isn't it coming from Google DNS servers? If you're saying, and where's it coming from? Well, it's coming from my DNS server, which is a pass-through to my ISP. But why isn't it coming from? And it would say authoritative answer would be if it was coming directly from Google's server. Why is it not going directly to Google's server? What do you think? Nicholas says that it is cached, and that is correct. It is cached, meaning that it's stored into memory on the DNS servers. The reason it does this is because we don't want to have to keep going out to Google's DNS server. Imagine that if every person that went to google.com, that they went to Google's DNS server every time. Wow, we would be hugely overloaded their DNS servers would be a little bit on the overloaded side. So we have the ability to do host aliasing, which is exactly what that is. It is basically taking like a www name and then basically, and it could be another name, folks, www, and taking that www and then converting it into multiple servers to do load distribution. We could do the same thing, mail server aliasing. Now, mail servers have a record called an MX record, and that MX can point to multiple mail servers in that company. DNS has basically a distributed database, a hierarchy of name servers. Okay. It is also an application layer protocol, layer 5. And when we look at that database, it has different record types. For example, an A record, and by the way, I always think of a database, this is just me, as similar to an Excel spreadsheet. So in one column, you would have basically the host name, and in the other column, you would have the IP address. This would be called an A record in the same Excel. And so usually what you would have, let me get my pen out. If we look in DNS, you would have something that, hold on a second, kind of looks like this. You know, if we were, this is always how I envision it when I think of a database. So here we would have, you know, the definition, an A record. Here we would have the name. And then here we would have an IP address. Sometimes you'll hear this referred to as a table with information. And so then I might have a C name, and I would have a name www, and that would point towards, you know, a server or a list of devices like this, you know, server 1, server 2, and so forth. So all of these different record types basically within the database contain different information in this table. And so we would have an MX record, and we would then have a mail server name and a IP address. We would have a name server, other DNS servers. That's what an NS record is. And if we go just take a quick look at our link over here, didn't key on it. Hold on a second. Let me go bring up. Okay. So here's that list of DNS record types from Wikipedia. So you notice you have an A record, returns a 32-bit address. You have an AAAA record, which is IPv6. So a name to a IPv6 address. And then you have other records. Look, here's that C name, an alias of one name to another name. We get down and we start looking. I mean, and there's a lot, folks. There's different types of records that would be in DNS. Here's that MX record, which is basically maps a domain name to a list of message transfer agents. Or, you know, we haven't gotten into mail. We are going to get into mail in one of the other chapters today. But basically, it's a way to say, hey, here's my mail servers. NS, okay, delegates a DNS zone to a given authoritative name server. In other words, this is another DNS server. And because it's an NS record, it's giving the name of our DNS server. Okay, I'm not going to go through every one. Another important one is SOA, start of authority. This basically says, hey, for this DNS zone, like mycompany.com, this is the authoritative DNS server. Okay. Yeah, let me share this if you want to mark it. You know, my chat session is weird this morning. It's like double spaced. Okay, so there you go. There's that link in the chat session. So all along here, I'm just picking out the most important ones, are basically the, different record types in DNS. Okay. Give me 2 seconds, get back to the, okay. Now, one of the things you need to know is the structure of DNS or domain names. First, you have what's called the top level domain. This is like .com, .net, .org. These are the three main ones that companies used to go out and try to get. Okay, and let me ask this question. So back in the day, you still had .edu, .gov, .military, but the main domains were .com, .net, .org. These are the three domains, top level domains. That's what they're called, top level domains. These were the three main ones that a company would get. And a company would go and get all three of these, even though they were a commercial entity. .net was more for networking companies, and .org was more for organizations of some type. But there was nothing prohibiting you from getting a net or an org. Let me ask you this. Why do you think that companies would, back in the day, go and get all three? Why do you think companies would go and get all three? Nobody? Okay. They would do it because they didn't want some company, because what a lot of companies would do abroad is, imagine you've got Facebook.com and somebody goes out and gets Facebook.net or Facebook.org. Well, they didn't want people to get mixed up and go to these other sites instead of their company site. So what they would do is go and buy all three. Okay. Yeah, so Nicholas said it right, to avoid people from impersonating that company. Okay. Lisa, it wasn't so much as they would run out, it was just because they didn't want anybody to impersonate them. So, Seth, whitehouse.gov, or that's the other thing that companies would do. And sometimes companies would go out and buy these weird domain names. If you notice in the chat session, whitehouse.gov, Seth put that. Well, a lot of times they would look at a keyboard to see what the possibilities of misspelling something. So the V is, or the B is right next to the V. So companies would go out, and when I say companies, nefarious people that wanted to advertise to you or get you to come to their site, but through mistakes or typos. And so some companies would go and buy the typos as well, just in case. Okay. They would buy the typos. So that is basically, the way that, I don't know how they do it. And by the way, some people did just go out and buy up domains with the hope that they would hit the jackpot. Okay. Companies that weren't on the internet yet, they would go buy the domain to hope that they would basically, get somebody would, they even went out and got people's names, like famous people, they would get their names as well, like brucewillis.com or brucewillis.net, hoping that Bruce Willis would say, okay, well, I'll pay you a couple grand or $10,000 to get my domain, So DNS is distributed in a hierarchy. Okay. If you'll notice down here, I wrote TLD. These are the top level domains like .com, .gov, .edu. At the top, they have what they call is the root domain. And then here you have the domain, and that is supposed to be, but it's not sometimes, what it is. Like this would be a commercial entity, educational unit, or gov. So Austin CC would be basically the domain name, and the top level domain for Austin CC would be edu. We can also have a subdomain, okay, like finance.microsoft.com. And we would then have some type of host, like, or even could be www as well. www.finance.microsoft.com. That would be a subdomain. When we look at fully qualified domain names, folks, this is what you need to know. Obviously the end portion, the last portion, .com is the top level domain. The middle portion would be the company, the educational unit, the government, the military entity, the network company, the organization. This would be the main name of, whatever they've got that top level domain for. And lastly, which a lot of people don't realize or know, is the server name. Okay. Now, www. Who knows what that stands for? Anybody know what it stands for? www? By the way, anybody that's answered this morning, I'm giving you 50 points for every question that you answered. If you're right. If you're wrong, I'm going to give you 30 points this morning. Why? Well, because it's Saturday morning and we should all be sleeping in late. So you get more points. Yeah, the World Wide Web. This was what the first server that was named. What most people don't realize is it's a server name, and they don't realize that, well, most people don't have a www for their server name. Instead, they have an alias that points towards multiple servers. So www is usually an alias name, just like you saw with the command window in Google, and it's aliased to multiple servers. Okay. So root name servers, there's 13 of them out there. 13 root name servers. There may be more now. The last time I looked, it seemed to be there was 13 geographically located. Okay. Now, let me ask you this, yes or no in the chat session. Do you think these root name servers have a listing of every single server that's out there? What do you think? Yeah, that's right. They don't. What they have is a listing of, we go back one slide, these top level domain DNS servers. And by the way, these are DNS servers that are out there, and they don't have a listing of all of, let's say, the .com, IP addresses. Imagine that, Google.com, imagine that these things loaded their DNS tables from every single company in the world. Well, it's impossible. What they list are two DNS servers. Two DNS servers, which is what's required to register a public domain name. And what they do then is they list Microsoft's DNS servers, or Facebook's DNS servers, or Austin CC's DNS servers, or one of the government web servers. Okay. That's what they list. It's a hierarchy approach. So the root name servers, these root, they list the top level domain servers. So they'll list companies that basically have all the .com DNS servers. And there may be multiple network companies, but they'll list in the root all of the DNS servers that do .com. Now, the top level domain servers, well, they're responsible for all the .com, .org, .net, .edu, and many, many, many more. Country domains like .uk or .fr. One company, Network Solutions, I don't know if they're still in business, they maintain servers for .com. Okay. And then, of course, education for edu. A top-level domain server is a DNS server that would say be a .com, and it would have DNS servers of companies, not the entire tables of those companies. It would just tell us, hey, go look at that company's DNS server. And then authoritative, well, that's the DNS server that the company manages. Facebook.com has their own DNS servers. If they provide authoritative host name to IP mappings, they provide the authoritative information for their web servers, email servers, and DNS servers. Now, it doesn't necessarily mean it's maintained by that company. There are ISPs that will maintain people's DNS servers. I myself have several domains, and GoDaddy maintains my DNS servers. I can go in there and make changes to them, but they set it all up and forwarded everything to those websites. Now, the other thing you can have is a local DNS server. Why a local DNS server? Well, because if you are a large company and at your company has tons of servers, tons of computers, printers, what you don't want to do is you don't want to have that DNS server on the public internet. So companies usually have two types of DNS servers. They'll have a local. So here we go. This would be an example. You have the internet, have a firewall, another firewall. You have a DMZ, demilitarized zone. And out here, you would have a DNS server. And that DNS server, and you would have also a web server. I'm going to draw, you might have multiple web servers. You might have a mail server. And so companies out on the internet that want to send emails to you, well, they have to do a DNS lookup first. They have to look for that MX record for the mail, because it's going to send it to this mail server over here, right here. So our user basically does a DNS query first. In other words, here we go, looking for what's your email server IP. And then what it does is it provides it back. Here you go. And then that gives it the ability to, let's say, okay, great, I got that now. Let me go talk to your mail server. So I could send somebody mail in your organization. But DNS over here, this DNS server is going to have public IPs. And by the way, when I say public IPs, it's going to be from this standpoint right here. These might be on a 172.16.1.0 subnet, but then I run NAT here, network address translation, to translate a public or multiple public IP addresses. I may have a pool of public IP addresses that I use for my communication that goes to the 172. I'm also going to open up only specific ports to these devices. So for example, like port 80, I'm only going to open it up to port 80 to my web server. Okay. And who can tell me what the DNS server is? What's the port for DNS? What do you think? What is the port for DNS? I'll give you 50 points if you get that. I'll give you a clue. It starts with a 5. Awesome. 53. So I would open up port. Didn't mean to do that. Hold on, folks. I would open up port 53 to get to this DNS server. So I would port forward port 53 going to my DNS server. But I only want, and by the way, that DNS server, I will only want if somebody's doing a DNS query here. I don't want to give them any 172.16 addresses. I only want to give them public addresses like this, 6.1.4.3. I just made that up. Okay. I only want to give public IP addresses out, nothing internal. Instead, in my internal network, looks like I'm getting a little messy here, I would have a DNS server, and that DNS server would be all my private addresses that privately my company needs for us to address server names. Okay. Does everybody understand that what I would have is two DNS servers? One DNS server to give out public IPs of my public IP range right here. And by the way, I might have a pool 6143, 6144, 6145. And that my internal IP addresses, for example, I might have a 10.1.0.0 subnet. The public wouldn't see those addresses because I have a separate DNS server that doesn't go or propagate to the public. Matter of fact, on this firewall port right here, I might block port 53. So there's no DNS traffic coming in or out of my device. Okay. And there's other things we would do in the configuration. Okay, so here we go. Here's a DNS iterated solution. Look at this, cispoly.edu. Okay, this is a educational, looks like the computer science department. And then down here, I want to get to gaia.cs.umass.edu. Notice this is a subdomain, folks. The domain name is UMass, University of Massachusetts. Okay, top level domain is .edu. Subdomain is CS for computer science. And so I need for this device to access this server that's out on the internet. In order to do that, I have to go to my DNS server and say, hey, I need the IP address of gaia.cs.umass.edu. Now, why do I need the IP address of this device? Because I've got to build my layer 3 header in TCP/IP. I got to give it a destination IP addresses. Networks and network devices like routers, they don't understand gaia.cs.umass.edu. They only care about IP addresses. That's it. A router looks at the IP address and routes it to its final destination. It doesn't look and go, oh, there's a Gaia CS UMass. Let me go do a DNS lookup for this customer that needs to access it. No, routers don't do that. They go, oh, let me look in layer 3. Do I have an IP address there? I do. So we go to our local DNS server, and our local DNS server says, ooh, I don't have that for you. So it goes and talks to one of those routes. It says, hey, I need to get the IP address of gaia.cs.umass.edu. Can you put me in touch with a .edu top-level domain DNS server? Sure, here you go. Great. Now I'm going to go talk to it. Excuse me, I'm looking for cs.umass.edu. Yes, it's going to ask about the domain name. I'm looking for, this subdomain. It's going to use the subdomain, top level domain, and then of course, oops, I should have said, my brain will fire here in a minute. Subdomain, domain, and top level domain. And the .edu says, sure, here's the IP address of that DNS server. Now your DNS server goes and talks and says, hey, I need the IP address of gaia.cs.umass.edu. Gaia being the server name, CS being the subdomain, UMass being the domain, and edu being the top level domain. The authoritative DNS server says, here you go. And now it reports back to your PC. Your PC now has the ability to go and access or fill that layer 3 header with an IP address to get to the final destination. Okay. And those requests can be cached, meaning that if somebody else over here in poly.edu, maybe another device, wants to go to this, maybe they're in a lab and they're like, okay, I need to get there. This DNS server is going to cache it. Okay. And there's usually a time to live exceeded that will come from this DNS server right here. Okay. That will come from this DNS server. Now, there is another one. It's called a recursive. How does a recursive work? Well, on the internet, we really don't use recursive, but in a company, we may use recursive. What is recursive? Well, recursive is where this basically host asks this DNS server, its local DNS server, hey, I need the IP address of this. Okay, except this would be a internal company. This works more when it's internal to your company versus external. And it would go out and say, hey, I need the IP address of Gaia. Oh, okay, I'll go talk to a top level domain. Okay, I'll go talk to the authoritative. Great, here's your answer back top level domain. Okay, here's your answer back route. Okay, here's your answer back local DNS server. Okay, great, I got it. But in reality, this really isn't configured on the internet this way. It is working like this on the internet, where your top level domain is going, hey, I need to know a .edu DNS server. Here you go. Hey, I need to know what the DNS server is for cs.umass.edu. Oh, it's dns.cs.umass.edu. Okay, great, thanks. I'm going to go talk to it. This is called an iterated, and this is what's used on the internet. This one here is used like in a company. Why? Because you control all of these DNS servers. And yes, larger companies have multiple subdomains. Okay. They may even gobble up a company, and that company already has its domain name, and they use trusted, basically, situations. They can go in and say, okay, well, we're going to trust your DNS servers. We're going to be the root DNS server, but we're going to take your DNS server and, put it as part of our network. So, and then you have a trust relationship so that you can pull data and basically transfer tables between all of them. So here's another example, DNS query. I'm not going to go over this just because I just did. This is in your book. And as you can see here, this device wants to talk to csberkeley.edu. So it goes to the root reports back. It goes to edu DNS servers, reports back, goes to berkeley.edu, reports back, then reports back to, and then goes to, because this is a subdomain, I didn't notice that, subdomain. It then goes to the subdomain DNS server, goes back, and then finally reports, okay? And if you see here, in this case, it's going to, the initial query is going from, the root, saying I need a top-level domain DNS server, to the edu or the top-level domain server, giving it the domain, and the domain is giving basically the subdomain. Now, I'm going to tell you this, a lot of times when you have, in this example, a subdomain, it's in the same DNS server. It's on the same DNS server. So I'm not 100% sure that it would go, because when I've set up DNS and you have subdomains, they're literally, it's the exact same machine. So berkeley.edu, it's just a different table. We have a different table for it. And so the same DNS servers are for berkeley.edu, also run csberkeley.edu. You just go in and configure it. Okay. So I'm not sure that it would actually go and do another query like this, as it would just give the answer back. Okay. Okay, registering a domain name. Out of curiosity, in the chat session, how many of y'all have your own domain name out there on the internet? Answer yes or no. Okay, a lot of you answering no. Easton, your wife does. Oh, and birdsongeventplanning.com. Oh, okay. So I have a bunch. Let's say right now, one of y'all are listening to this and you're going, I want to start my own business. Maybe you want to start a computer consulting business in your local town or area. Okay. And you decide, okay, I am going to start. Well, first off, you have to go to a domain name registrar. Okay. They're going to register you for it for you. First thing they're going to do is check, does it exist? Has somebody else using that DNS name, that fully qualified domain name? For example, wadetshirts.com. Let's say I wanted to start a company making my own Halloween t-shirts. And I decided that I was going to call it wadetshirts.com. And I would go out to a registrar. For example, GoDaddy is who I use right now. I would go to GoDaddy and I would say, hey, I want coolwadetshirts.com. And I go and I'm like, oh, it's already out there. So I got to come up with another name. How about, just cooltshirts.com? Okay, that's available. And then what they do is they'll register that and they'll automatically configure a primary and a secondary DNS server. Now, if I want to, I could already have my own DNS servers out there deployed on the internet. And if so, when I register, I give those DNS servers. You have to have at least two, okay, out there to register a domain name. Once you register your domain name, it takes about 24 to 48 hours for it to propagate across the internet. Most companies like a GoDaddy, they will set the DNS that it points to one of their pages. Like, you too can get a domain. Okay. And until you have a web server. Now, you may have purchased a little package that allows you to get a web server as well, and they'll point it to that web server. And usually it'll say, coming soon, wadetshirts.com. And then you can go into a GUI, a browser-based GUI, graphical user interface that allows you to, add photos and pictures. Maybe even you paid for the more expensive version that allows you to sell products online. And so then you start basically putting in your products into that device, that website. And eventually you are selling products online. So they create a type A record, www, Network Utopia is the example here, and then they'll also create an MX record. Some companies want you to have a mail server. And speaking of which, yeah, I got to remember to do something there. I do have a domain name, and recently GoDaddy really torqued me off because they actually changed it over and changed the way they do mail, meaning that they didn't do it free anymore. And what really bugged me was that I got free use of Microsoft Exchange. They went with a Microsoft Exchange environment, or Outlook. So it was Outlook, different mail server program, and they want to charge you a monthly fee. And what I haven't done is, I think it was supposed to expire. Probably need to check and see if I'm still getting emails from my domain. Okay. So now, what software do we use, and why are we discussing this? We're discussing this because we do set up software on Unix systems to do DNS. Remember the diagram I just showed you where we had a internal DNS server and an external? Well, a lot of times those external DNS servers will run with Unix. On the other hand, internal will run with Microsoft's DNS. As a matter of fact, Microsoft is nice because it does use a GUI. And why do I think that's nice? Well, Bind is the main one that I have set up. And I've also done Microsoft DNS. And when you set it up, it's literally you're editing configuration files manually with VI, okay? And probably some of you have seen with VI, you know, if you're used to it, great. But if you're not used to it, you know, it's difficult. And let me tell you, so I worked for this company and we used Bind. They were mostly a Unix shop. They weren't Windows yet. And we ran our DNS using Bind. And so when we wanted to add a server to it, we would do VI and we would go add the server to it. Problem is, every once in a while, somebody wouldn't check their work. One of the administrators wouldn't check their work, and they would create a typo in here. When they created the typo, literally half of the DNS table was no longer available, wasn't reading it properly because they had, you know, not properly formatted the line that they added. And so all of a sudden, half of your servers are no longer able to communicate with using a fully qualified domain name, which means customers are now yelling that, hey, I can't reach your, you know, the server to pull my data. Or data feeds that you have coming into a database, they stop. And so what did I do? Well, I had the chief operating officer came by because he knew I had Microsoft experience. And he said, hey, can you install a Microsoft Active Directory domain and bind all the PCs? Can you do that? I said, sure, I've done that before. And so we moved our DNS as well over. And there was no more half of our, you know, systems not able to access because this just comes up and pops up and allows you to enter one domain name. The only thing you could get wrong is the IP address or the name of the device. What you couldn't do was mess up the tables because it was a GUI and it was GUI driven, the whole DNS process with Microsoft. So sometimes you'll hear us Linux people say GUI, yeah, that's for those non-computer people. But in reality, sometimes that GUI helps us out because, oh, less mistakes when you can only do one entry. So only that one entry, not half the table or 2/3 of the table being corrupted because somebody did a typo. There's other ones here, NSD, Power DNS. You'll notice bind 80%. And you know, when I look at this statistic, you know, this was July of 2009. I look at the statistics, I'm like, yeah, but what about internal versus external? Because probably this was taken from an external perspective because you can go sometimes and probe DNS. They're supposed to have it turned off, but you can probe DNS and it'll tell you, oh, I'm running bind version, blah, blah, blah. That, of course, is not secure. You want to go and turn off any labels that label what the web server version is, what the DNS server version is. And there's other, look at this, comparison of DNS server software. There's other software out there that we could go and basically look at. Myself, here we go. So look at this. There is other bind, DNS dist. Look at all the different ones. You know, Microsoft DNS. Those are the only two that I've really used. I haven't used the other ones out here. And here's a comparison chart telling you their functionality, what they can and can't do. I primarily used Microsoft DNS and, of course, bind. Now, how does our system on the Unix side know what DNS servers to go talk to? Well, there's a file in ITSC called resolve.conf. ITSC resolve.conf. Look at this. It's in Linux, Solaris, HPUIX, AIX. All flavors of Unix have this file out there. And what it does it tells the system what DNS server to go talk to. Now, you have the same thing on your PC. Similarly, it's not called resolve.conf. Where do I, in the chat session, tell me, where do I go on my PC to tell my PC what DNS server to go talk to get that fully qualified domain name to an IP address? Where's that at on my PC or other Windows servers or Windows devices? Where's it at? Okay. Looks like I got a couple of folks. Let's see. Hey, James, I'm not sure what the up arrow means. You're not sure? Is that what you're saying with Shada? Okay. Okay. Folks, if you don't know this, you need to write it down. Okay. Here's the thing. Depending on what the position is that you are looking for, if you don't know where DNS is configured, and Easton had it right on the money. Easton, I'm giving you 100 points for that. Nicholas, I'm going to give you 80 points for that. And for those of you who didn't know, you still get 10 points. Here's the thing, folks. There are just some things you have to know in this industry. Okay. And if you don't know it, build you a little lab at home. Do it several times so you'll remember, okay, this is at. The more little devices you put into there and configure, the more you're going to remember. Also, take notes. If your only method is note taking, write it down 10 times. You've got to know this stuff. But if I go into settings, we can start from settings. Okay. Another way is go to the control panel. If I go here, see where it says network and internet, I could go that route. There's always a couple of different routes. But you could have gotten this by saying, hey, I go configure the network interface controller card. Okay. The network interface controller card. In my case, I use Ethernet. I hook directly up to my wireless router. I don't want to use wired. Okay. And sorry about that. I'm clicking too fast. If I go to Ethernet settings and I go change adapter options right over here to the right, it's going to pull up all of my devices. So here's all my devices. I'm going to go into the Ethernet because that's what I said. By the way, the other ones are VMware adapters. I'm going to go properties. And right here where it says IPv4, here I've set a static IP address. And notice right down here, use the following DNS server addresses. Now, if I click obtain one automatically, obtain an address automatically, it'll get it from my wireless router through DHCP. But in the Windows world, the network interface controller card says what DNS servers to use right here. And look at this. I could go advanced. And if I wanted to, I could click on DNS in this tab and I could give it more DNS servers. Okay. This I gave manually to it because this is a static IP on my device. I did that because I didn't want DHCP causing issues when I was trying to do a WebEx session. So I gave this a static IP address, just like you would do servers. Okay. But this is something you need to know. If you're in an interview and somebody says, well, how do I configure my desktop PC for, let's say, IP address and DNS and, where would that be configured at? You should say, oh, that would be configured on the network interface controller card. I can go to the settings, and in the settings, I can go to network sharing and get there. I mean, we could have gone there another way. We could have just gone to our settings over here. And by the way, it used to be just go straight to control panel, but they've made that a little more difficult to find as well. But here we go, network and internet controller settings. There we go. And look down at the bottom, change adapter options. So what did I do? I went to settings in Windows 10. Okay. I clicked on network and internet. And then I clicked on down here, change adapter options. And up comes my window. And then I just select whatever controller card is. Notice I got a Wi-Fi card. I could have right clicked and done Wi-Fi. Unix is a little easier, right? I don't have to have this menuing system, that Microsoft changes with every version, okay? And making it more difficult to find what I'm looking for. That's the thing that irritates me about Microsoft as well. I don't like the way that every time they come out with a new version of the software, well, now instead of, like for years, I went to control panel like Easton suggested, and it's still there, but they just make it more difficult to find it. Now you go through settings. Okay. So folks, on this side of the house, the Unix side, we configure the resolve.conf. Here's a configuration file. Now, see the search here, example.com and local LAN? In the Unix world, when I type in a host name, like I want to go, let's say I have a host name that's called server 1. There we go, server 1. And I want to go out to that machine. Well, in DNS, it's not going to be called server 1. It's going to have a fully qualified domain name. So when you type this search right here, what happens is it takes whatever these search domain names you put, and it appends it without you having to do it. And it goes in queries DNS, and it queries in order. Here's the DNS servers that's going to query in order. And it'll go server 1 example.com. Then it'll go server 1 local.lan. It'll append this name to it. And it'll search DNS with those names right there. Now, another thing, before I go out to a DNS server on a Unix system, even a Windows system, I search something else first. What do I search to find that IP address? What do I search? What do I search, folks? What do you think? Yeah. Yeah, the local host table. And this is something else that you need to know. I've asked this question as well on somebody that came in and said, yeah, I know Unix. I'm like, oh, okay. Where do I go and look if I want to get a, IP to host name match? And I don't want to go to DNS. Well, both Windows as well as Unix has a local host file. And I'm giving 50 points to Nicholas. And Easton, I'm going to give you 40 points because you didn't put the full path there. ETC hosts. There we go. That's what it looks like. You'll notice here, not much here in this one, but you'll notice that this is the format. See, we have an IP address and a host name. This would be our local host name right here, the one that we have here at ACC. So this is the IP address of it, and this is the host name. We often use local files for permanent server names. Here's the thing, folks. If DNS has problems, you can't get out there. So when you have a data center And that data center has got a, let's see, hold on a second. Get my pen back. When you have a data center that has a server, a web server that talks to a app server that talks to a database server. Well, if you've got DNS out here, you don't want these things every time they need to go talk to head out to each other, to head over to the DNS server. Yes, it will be cached, but still, it at some point has to go back to the DNS server. If that DNS server goes down or starts having problems, well, then these have problems. And believe me, these are real world problems. I've worked in environments where app servers stopped communicating with web servers or database servers, and it turns out that DNS was having problems. So what do? You put that etc host file out there. That etc host file has the web server, the app server, and the database server's IP address, just like you see here. I would have basically the IP address of the web server, the app server, the database server, and what their fully qualified domain name is, or their short name. I don't necessarily have to use this. I could just say app server 1, app server 2, whatever their short name is as well. Now, there is a file out here. Let's see if, I got to be an ETC. It's called NSSSwitch.conf. NSSSwitch.conf in the Unix world tells what order to basically go do lookups, like host lookups. So if we look at this, you'll notice that in here, it will have hosts. See the host right here? It'll have files. Files means go look in the etc host file to find it first. And then you got mdns4 minimal. I haven't seen this one before, but you've got DNS. And then I don't like this in here. I've seen this cause some strange problems. I usually like to put files and then DNS. Okay, I haven't seen that one. I would need to look it up. This one is a little different. I'm used to seeing files, DNS, or files, and another one is called NIS, Network Information Systems, and DNS. But notice files is first. Whenever you see files, it's going to look there first. Okay, and then you have this compat mode. Compat mode means it's going to look in etc password, but it can also do LDAP as well. There's LDAP and there's NIS there. Usually if you have it in compat, it just means compatible mode, and it'll look in multiple, LDAP or NIS, depending on what you have. But this NSS switch file tells the system where to go look for passwords, where to go look for group, where to go look for the shadow file, and where to go look for hosts, networks, protocols, services. So that's what the NSSSwitch.conf is for. So resolve.conf or a local host file, etc hosts, or on the Unix side, on the Windows side, it also has a local host file. If I go out to the C drive, here we go. Here's my C drive. I go to Windows. I go to, where is it at? System 32. I go to drivers. I go to ETC. See, notice, I think it's hilariously funny that, that they named it, for Unix, like ETC. I'm like, yeah, that's Unix. What, they copied it. They got lazy. Okay. So here we go. Windows System 32 drivers, ETC, and there's the host file right there. I could edit this and open it up with Notepad. And here we go. Same similar format. They're showing you here IP address, and then I could have a fully qualified domain name, or I could just have a host name like Rhino. I didn't have to put rhino.acme.com. And then here, look, this 000 means local. It's going to access this locally. Okay? So that's an ITSC host file on both Unix and Windows. Okay? So when it comes to these DNS servers, when we set up the DNS server, we set up more than just one DNS server. Okay, that's what you need to know. And they do have, kind of different names associated with them. So for example, you may hear, when you hear authoritative, oops, hold on. When you hear authoritative, well, that means that that DNS server has the authority to give out IP addresses for that particular domain. Okay. So Facebook.com's DNS server would be the authoritative or the official representation of a zone. You have primary and secondary, meaning basically most go to the primary, but then the secondary is kind of like a backup. It has a copy of all of it. Then you have a stub. Okay. It just has a copy, only the name server data, not host data. You have distribution, a server advertised only within a domain name. And then you have non-authoritative. Once again, non-authoritative means a query from a cache. You don't even know if the data is still valid, but usually those non-authoritative answers, they're cached for only a certain period before they have to go back to the authoritative and basically reread and get a DNS address again. Okay. Forwarder, well, it performs the queries on behalf of many clients. It builds a larger cache. Recursive queries on your behalf until it returns an answer or an error. And non-recursive refers you to another server. Here's what a file looks like. This is what, if we were to manually look at a configuration file for a zone, we call them zones, okay? We have reverse lookup zones, which is IP to fully qualified domain name, okay? Give me 2 seconds here. Sorry about this. And okay. So if we take a look at this file and kind of take it apart, what do you see? Well, over here you see names. Then you see the record type. And then over here you would see, well, different information. But let's take one apart. Here, look at this, SOA record, example.com. It means this file is the authoritative answer for example.com. And you see these over here, well, this is a serial number. Whenever we change one of the records, the serial number changes. Notice NS, excuse me, is a name server record. This is basically the DNS server name. Notice there's no IP address associated with it. And here's another NS, and here's a name. All it's doing is it's giving me, the NS record is giving me the server name for the DNS server. Notice down here, I have NS once again, but this time it's an A record with an IP address. So what you've got here is NS. So somebody out there that wants to talk to our DNS server would go, hey, I need to know what the DNS server name is for example.com. the DNS server would say, oh, it's NS. And the NS A record IP address is 192.0.2.2. And the AAA record, which is the IPv6 address, is 2001:DB8:10::2. Notice I got a web server, and look, it uses a CNAME, and it refers it to example.com. Well, if I look at example.com right here, the domain name, here's the A record and the AAA record. Here's the IP address. Okay. So you see a lot of these are like little pointers. A CNAME is pointing to a alternate name. So look at this, www test points to www. www then points to example.com. Example.com points to the A record and the IP address 192.0.2.1. Here are 3 mail servers, mail 2, mail 3, and the associated IP addresses. Notice the 3 MX records, an MX record meaning it's a mail server. Now, when we configure Unix DNS servers, we have to go in and type all this in. Now, don't worry if you're like, oh my gosh, that's a lot to type in. It is. But what we do is, there's usually a template file that comes with DNS that will start this out for you. You just have to go in and fill in your domain and start filling in MX records. But all of this is done by hand, and there are some web-based GUIs that you can utilize to do this as well. We used to do this all by hand. And so what would happen is somebody would, forget to type in something. Notice the dot at the end here, okay? They would forget to put the dot in there, or they would forget they'd put a semicolon in, not get the semicolon in there. And the next thing you know, it's using all of this, and down below is just counted as nothing, okay? And so that if this thing isn't formatted correctly, well, then it doesn't read the stuff below. And all of a sudden, your mail servers aren't getting any communication because there was a typo up here somewhere or a character out of place. And now it doesn't read below that. Okay. So colon introduces a comment, the @ symbol, current zone names, parentheses allows you to span lines. And then, of course, this is a wildcard, meaning everything. Here's more of those DNS records. Start of authority, NS for name server, A for IPv4 address. That is a name to address. And this is another one. See, a pointer record, they call it. They use pointer records in reverse lookup tables, meaning that if we were to go look at that table, it would have IP addresses here, and this would say PTR, and it would have a name over here, okay? IP addresses would be first because it is a pointer record. They call it a reverse lookup table, okay? MX record for mail exchange. You can also have public keys that folks can go validate your DNS server to see if it has a public key. And then, of course, CNAME, and we can also have some well-known services out there as well. Here are versions of bind shipped with example systems. You've got, bind versions according to, and look at all of them. So everything uses bind. And by the way, you can actually get a nice little thick book on bind itself. Now, how do we configure bind? Well, named.conf is the configuration file. First off, the file that I just showed you, that was a zone file configuration. In other words, look at the zones here. This is the config file, name.conf. I got a zone called localhost. I've got a zone, and look at this. See this 000? This is local, but this is what a reverse table looks like. You will have basically whatever the IP range is. This would be an IP range, .in.address.arpa-a. This is a reverse lookup table. Okay. Actually, Easton, the solution, yeah, you can. There are sometimes with bind later on, they came out with you could run a program and it would actually check and validate the tables. But getting an administrator to do that is another case. Like, hey, check, run this program. Also, Windows Active Directory, we used internal DNS, and it was 10 times better because you couldn't get a typo on a configuration file like you just see here, because Microsoft is building this table on the fly with the GUI. So the only thing you do is you enter like a host name, mail, and an IP address, and you click the button. They even have a little checkbox that it'll automatically add it to the reverse lookup table. Okay, that pointer record, it even says PTR. Do you want to automatically do the pointer record? Yes, and it builds the table. I mean, yeah, we moved over to DNS, and after we moved over, we didn't have any problems with DNS going down due to a typo, ever. Okay, for our internal web. We still had in our DMZ an external DNS for, basically private addresses, and there wasn't that many. Okay. I mean, because we only had like a few web servers and FTP servers. So we weren't the companies I've worked for doing DNS where I set it up weren't giant companies. They were, small companies. Okay. So this is the configuration file, and you have to have these files out there or it's not going to work. We have to have a reverse lookup table. We have to have our localhost.zone. Okay. And in actuality, this isn't a good example that the author is using. A better example would be, zoneexample.com. Okay. And we would have that file that you just saw. Now let's go. Hold on a second. Pull this up. So you want to set up DNS? Well, here you go. Notice here's a zone file right here, and see the zone here, land5.com. Well, that's the land5. That's where it would go. Once you run and bring up bind, it takes this configuration file and goes and loads those zone files. The zone file that I just showed you 3 slides back, that zone file then would be built into a little database. Okay, it would read it, build it up, and basically run it. And here, look, see this zone 206.177. Well, notice how it looks. Okay, that is a network address. It builds these network addresses. And look at the title. This is this thing I always found the strangest. It's the reverse. Look, 206.6.177. You got to look at the reverse. And it does do it this way. It's weird. I'm like, okay, who thought that up now? When we were designing bind, who's the guy that said, well, let's do it in reverse? Yeah, that's cool. Let's confuse people. It always amazes me, some of the technology. And I really would like to go, hey, just curious, why'd you do that? And probably they're going to say, I just wanted to mess with people. Yeah, I mean, okay, look, we named it what the network should be, 206.6.177. So we named that zone file, okay, like it should be. But yeah, we thought we'd do it this way. That was cooler. We thought we would just invert it. So anyways, now look, a DNS server, notice, has root servers listed in it. By default, this is already built for you. This basically tells your DNS server what root server to go contact in order to find those top level domain servers. Okay. This is called root hints. Hey, I need to know the root servers. And what it'll do is it'll go out and talk to that when you first come up, and it'll rebuild it. Here's a zone file for localhost. This is a pointer record. It is 127.0.0 and .1. Notice that because this is a network address It's just using the last host portion in the zone file. Here's land5.com. This would be for the DNS itself. And notice that up here at the top is a lot of information. Start of authority. We are the land5.com. And look, they got another one here, root.land5.com. We are the authoritative DNS server for this domain. Notice these dates. Here I've got, expire 4 weeks, retry 2 hours, refresh 8 hours. These are times for the cache, folks. So once these when you pull something, it gets this information over on your side, and it uses these to either refresh your cache or retry if it doesn't get an response, or expire it completely. Okay. And then up here is the serial number. It is today's date plus some type of number. Okay. Usually it's today's date. And every time you change this file, you have to change the serial number. So when we're changing this manually, you have to change the serial number when you change something. Otherwise, the DNS, the bind process, will not reread the file. When you change the serial number, it goes, oh, serial number changed, reread it. Oh, we have a new entry. Welcome to the team. Notice, look, router. So this would be router.land-5.com. Here's the IP address. It's an A record. Notice the C names. I have FTP mail news going to land5.com. And if I look for that land5.com, here I see it. And here's the IP address to some server that's out there that is doing both FTP, mail, and news. Okay. And then look, here's all these workstations that I have. Here's the MX records for the workstation. Notice it's all sending it to the same mail server. I've never seen this done like this. Usually all you needed was one MX record, like right here. That's all you needed. Okay. Okay. And then here's another zone file. This is the reverse lookup file. Notice 206.6.177. That's the network address. And notice here, .1. And notice how they're pointer records. Notice how their addresses here, like 200, 201, 202, 203, 204, is pointing to a fully qualified domain name of a device. So this is also called a reverse lookup table, looking up the IP address and the associated fully qualified domain name. And like I said, on Microsoft, you're using Microsoft DNS, and see it says reverse zone. We often call it a reverse lookup zone. Now, folks, this URL is in your book. Okay. If you look here at the contents, how to set up, if you wanted to play around or set up, and I'm going to put this in there. I'm going to put it into the chat session. There you go. Bang. If you wanted to set up DNS, this is a really good, this author did a really good job. Bind 9, basic security concerns, setting up a simple domain, and you could play with this. I don't have a setup DNS, but you could set up DNS. We're going to be doing other items, but if you wanted to set up DNS, here is a very good tutor and how-to. Okay. Now, another DNS server, I haven't used this one, is NSD. Okay. You have different binaries, regardless of which DNS server it is. Once again, here you go. Here's a nice URL, NSD. If you wanted to set up, and I'm not going to give you that, you can go into the chat session. I wouldn't recommend you use NSD, or here's another one, Unbound. I would still use bind because most are bind. Okay. Here's some security features that we have in all three of them. You'll notice that when we look at DNS, one of the things that we have to look at is who can request zone transfers. In other words, who are you going to allow to dump all the tables? those files, the configuration files that I just showed you. Let's go back and hold on a second. Let me go back to that. I must have closed it. So hold on. Go back. Just want to make sure everybody understands. And here we go. Okay, so all of these zone files that you see here, right here, this is LAN.-5com. This is a file. It's just saying it's a flat file. What happens is bind or runs, and what it does then is it reads this file, and when it reads this file, it then loads it into its cache, and it's like a little database file that you can query. But here's the thing. Imagine that you could go dump all of this or transfer all of this. Well, that is called a zone transfer. Okay, a zone transfer. And the problem with that zone transfer is, well, it has a little bit of security ramifications, right? Imagine a hacker could dump your zone files and then look at all the servers that you have listed. Now, the other problem is that, well, they could just go and do queries of your system. So a public DNS server is a little hard to not allow it to basically go and grab all the data out of it. Whereas a internal DNS server, you can be more explicit to say who can do zone transfers, recursive queries. What about an access control list? Who can access it and can't? So we can lock down our internal DNS servers pretty good with some security features. You'll notice here bind, and then you have NSD and unbound. We could do a change root. We could lock DNS to only the DNS directory. So if somebody hacks in through some kind of flaw, well, they're only going to see the DNS directory. We can also have logging as well for, pretty much all of them. You have different categories, different modules, and a facility. Remember, we went over syslog and we discussed the facility and the severity of the error. Well, bind, okay, basically can send to syslog any logging information. You notice here's some predefined logging channels: default syslog, default debug, and standard error. These are syslog is going to use it. Here's some bind logging categories, meaning what it could report. Hey, the configuration file has an issue. Hey, I got some client requests that you need to know about. Okay. General catch-all for unclassified messages. A lot of times when we're troubleshooting DNS to try and figure out what's going on, well, we can put it in a debug mode so we get detailed information about each of these. For example, maybe we're having problems with zone transfers. So we could literally see all of the zone transfer. And by the way, I've had to troubleshoot some DNS problems where we had DNS servers that were geographically dispersed. For example, the main DNS server was in our corporate office here in Austin, but we had a New York office and it wasn't getting zone updates. They weren't doing zone transfers. And so I had to put it into a debug mode in the log and actually look to see what the error was with the zone transfer. We also have some, utilities or commands that we can run that interfaces with bind. So for example, bind includes a utility called RNDC. It allows command line administration of the named daemon. Now, folks, don't ask me why they decided to name it bind, okay, versus, the daemon is named, is called named, okay? So if I do a PS minus EF, a PS minus EF, well, then I would see a bind process. Hold on. Okay. Now, why did they call it bind here? You know, and when I say I don't know why, I mean, okay, why wouldn't you call the daemon bind then? Bind stands for Berkeley because it was developed by college students, Internet Name Domain. And honestly, that's why I think sometimes you see crazy stuff. It was developed in a university by students and they wanted to have some fun. So they said, hey, let's confuse people even more. Yeah, let's call the daemon the named D. Of course, you know, all daemons have usually a D in the back of them, like SSHD, which is the SSH daemon. So here, name, well, it's a name service, okay? You know, domain name system. Yeah, so we'll call it named, but okay, the software is called Bind, Berkeley Internet Name Domain. I mean, I don't know, you know, I'm like, yeah, that sounds logical. Yeah, yeah. Or instead of calling it, you know, the bind daemon, like BINDD, yeah, let's call it named. Let's. So that's just me. There is a you know, etc name.d conf file. This is what we usually to configure bind. And then there's also for this command a configuration. But here's some of the stuff that we can do. We can flush the cache, meaning we want to just clear the cache out. Okay. We could freeze a zone or suspend any updates to that zone. We could reload the config file. We just changed it. So I could do an RNDC reconfig and it will the DNS or this name daemon will reread the config file. I could do a reload as well. And this would reload the name.conf file. In other words, let's say that I added a new zone file into the name.conf and I wanted it to reload this name daemon to reload the config file, the comp file. Why? Because I got a new zone file. Okay. I could restart named D. So all of these commands using RNDC. So RNDC is at the front of it. And then here is the argument you would, you know, type in to do something, is basically operating on this named D daemon right here. Okay. Another program that we could use is NSDC. Okay. This is where you're getting into these other programs like Unbound, which we just mentioned. Okay. Or NSD. And I can start it, stop it, rebuild it. Same similar commands that Bind uses, although Bind has a lot more, but it does have some of the same things. Start, reload the zone again, restart. So update all of our, you know, secondary servers that are out there. Here are some of the bind files in Linux. The biggest one is resolve.conf to go see DNS. The other one for bind itself is this named.conf. This is the main configuration for bind, which is going to tell us what zone files to go look at. And I already mentioned the nsswitch.conf. It tells us, hey, do we want to look in the local host file first, which is usually the default, or do we want to go look at DNS first? No. Here's bind 9 files in Solaris. Very similar. You don't see any differences here. There's the resolve.conf. Okay. The name D is the daemon. Name.conf and nsswitch.conf. Those are the two main config files. NSS switch, once again, it's going to tell it where to look first in order based on that file. Hosts first or DNS first. And the name.conf file is where we would go in and tell it what zone files to load. Here's bind for HPUX. Notice once again, resolve.conf, name.conf, nsswitch.conf. Configuration files are the same. Might be in a different location, like here, look, namedb, but it's all under ETC. Here's AIX, IBM's AIX operating system. Same thing, name.conf, resolve.conf. Now, they do name their NSS switch is named differently. They decided to call it netservice.conf. And then there's another one out there called irs.conf for services, meaning, okay, where do I go look first, hosts or DNS? And folks, that's it for DNS. Any questions? Any questions? Answer no in the chat session or feel free to ask a question. Okay, well, I tell you what. Chapter 17 is our next chapter. We're going to take a break, though. This is single sign-on, and it is 10:08. Let's start back at 10:15, about a 7-minute break. So start 10:15 a.m. and I'm going to pause the recording. About a 7 or 8 minute break. Resume the recording here. And chapter 17. Okay, folks, single sign-on. Who can tell me what that means to you? When you see the words single sign-on, what does it mean? What do you think? Answer in the chat session. Let's get the brains firing again. Amelia says we use at the job password for one password for multiple applications. Using a single account to access multiple systems, only one sign-in is needed. One password for multiple apps or a website, single account. Yeah, one of the problems that they had was you had Unix users, you had Windows users. You also had multiple applications out there, web-based applications as an example. And so, wow, back in the day, you had to keep account of all of these different accounts, different usernames, different passwords. And of course, even today, you still get where the Unix environment and the Windows environment is separate. It's not single sign-on. You have a separate username and password for both sides of the house, the Unix side and the Windows side. And you log into some application that is Windows and you have to use a different username and password. You log into an application that is Unix based, different username, different password. So they came out with a need for having a single sign-on, meaning that you could use the same username and password for multiple systems, multiple OSs, multiple applications. Okay. So LDAP was the biggie. Lightweight Directory Access Protocol. It had a database with personal information, employee names. You could put usernames in it, phone numbers, emails, and office locations. And a directory service is just the database. That's what it is. Now, it's not a database that is going to have 2 tons of information. It was meant to be a basic, database that just included information you needed to log in, or what groups you belong to, what servers you were allowed access to. So it wasn't a database. Yes, it had phone numbers and emails and employee names, but it wasn't a database that really, say, would have 2 tons of data about you. Okay. These data objects that they contained were small. The database was easily and widely replicated and cached, meaning I could have more than one LDAP server in case my primary LDAP server went down. The information was attribute based, and data was read often but written infrequently, meaning that if you think about it, when you hire employees, when you bring in computers and install them, you're not doing that every day, okay? Unless you're a brand new company and you're just starting to get people in. But for the most part, when you go into a company, it's not like you're going to go, oh, we got 1,000 employees coming today. Oh, we got like every day you got 1,000 employees coming. So you're constantly writing all that information. You know, you might have 2 or 3 employees in a large company, 2 or 3 employees or 10 a week. And that is, you know, tiny amount of data that goes into the database. You know, it's not like, let's say you have an application that is a shopping application and people are constantly buying products and you have thousands of transactions going on every day. Searching is a common operation. Why search? Well, because it's searching for those usernames when somebody logs in. Okay. So LDAP, here would be an example. They're just showing you what an LDAP entry would look like in their database. So instead of using a local password, and by the way, before LDAP came out, we used to have scripts when we would add a user that would copy it out to all the Unix servers. Okay. You know, it's funny, you know, you see this stuff and I can think back of when LDAP didn't exist. Instead, we had shell scripts that, you know, we had a administrative server, which is where we kept all of our shell scripts. We had root access. Only the administration staff had access. And we could run a script that we would write that would go, okay, what's the username? What's their, you know, we would answer prompts because we wrote something that used prompts, similarly to the script that you wrote that said, hit a 3 for, you know, to get disk space, hit 2 to get the, you know, we did the same thing, except it would prompt and then it would go out and run and it would add it to basically all the password files that were out there. So that person could log into all the Unix servers or a group of servers. We could also in it, we could say, okay, give them access to this list of servers. LDAP, on the other hand, well, it's a database. And what it would be like this. So they would identify a UID. The user ID would be GHopper. They also call this CN a common name, which would be basically Grace Hopper. Here would be the user password. Their login shell would be bin bash. Their UID would be 1202, user ID. Their group ID would be 1202. Home directory, home GHopper. But when we would search the database, we would use something like this as a search string. And when I say search the database, this is all done behind the scenes, okay? You can use tools, though, to actually go in and enter these search terms to search a LDAP database. So here, this is saying we want to basically search for a UID of GHopper. They're in an organizational unit of people in our domain of navy.mil. Okay, this is the how they designate the domain. And LDAP usually, when it's configured, is configured in a domain. Windows Active Directory on Windows servers 2012, 2016 use LDAP. Active Directory uses LDAP as part of it. Okay. And then here you can see these abbreviations. O for organizational, OU, organizational unit, CN, common name, DC, domain component. That's what DC is. Domain component Navy, dot, domain component mil. And then object class is a schema to which they, you know, the entry attributes can conform. So LDAP can act as a central repository for all information about your users and phone numbers and addresses. You can use LDAP to distribute configuration information for applications like SendMail. We can draw a large part of their routing information from LDAP. With SendMail, for example, we could have list of alias names like jwade, meaning jwade@mydomain.com aligns with, you know, James.Wade. LDAP makes it easy for applications to authenticate users. Yeah, so what we did then at this point, once LDAP was around, we would have an application. And we would take that application and we would connect it up with LDAP. So here we go. Here is a web server of some type. and maybe we are running a finance program, or the finance where people can log their hours. And out here, we have our LDAP server out there. And what we would do is a user would pull up the web server, and the web server then would go, and because those applications used LDAP, it would go and say, you know, check LDAP, check the username. Oh, yep. Is the user actually allowed to log into this server? They are. And okay, what's their password? Is it correct? They are. Give them a login prompt. Okay. We could also, with LDAP, set up groups. So maybe this user that logs in, Jay Wade, is just a regular, in the employee group. They're just allowed to enter the time. But maybe, oh, I don't say, let's pick on somebody this morning. Sorry. Lisa. Lisa logs in, and Lisa is allowed, is not only in the employee group, but is in the finance admin group, okay, and is allowed, their actual window or their GUI looks different than my GUI, okay. Lisa's GUI looks, has some administrative tab in there that they can go in and do configurations in, okay. So that was some of the functionalities when it came to application that it would allow us to do with LDAP. Changes to LDAP take effect immediately and instantly, meaning when I log into LDAP, if I add a user, it's immediately available to other applications. It's easy to access LDAP data through command line tools such as LDAP search, and it's well supported by common scripting language like Perl and Python. Okay. And hold on, I'll show you something else. Give me 2 seconds here. See if I can find it. Yeah, here it is. So this is one of the tools that I've used. So I've gone in before, and I'll go back one slide. I've gone in before to install an application, and I might not control Windows Active Directory because I was a Windows administrator long before I was a Windows administrator. I might not have access to the Windows administration like Active Directory. So they would want to, the application I was installing, they would want to connect it up to LDAP, but I needed LDAP information. What information did I need? I needed this right here. And I needed to basically use this and I would say, okay, I need you to create an admin account in LDAP for this application, for the, we'll say the finance application. So finance-admin. And I need this right here because this was required in order to go in and configure this finance application so it could go out to LDAP and pull information, because you had to have permission. And I would get a lot of times administrators that had no idea what this was. Literally, they didn't know. All they knew was how to go into the GUI and say, here's the account. And I would say, okay, well, what's their UID? Or actually it didn't use the UID, it uses the CN. Some of them use the CN. I say, what's the CN? What? I'm like, the common name. Do you have, I need the address in LDAP. See, this is like a little mini address in LDAP of where to go to get this information. If I want information about Grace Hopper, I can use this and search for this, but I have to know what their organizational unit is and what part of the domain they are in, because you can have more than one domain. We could have navy.mil, or we could have subdomains, finance.navy.mil. And so they would know this. And I'm like, seriously? Okay, you're in charge of the domain controller, and you can't give me the, what the address is. So what did I do? I said, okay, no problem. How we go? Let's download JExplorer. And if you look here, it's pretty cool, actually. Let me zoom in. So JExplorer, and the J standing for Java. It's a little Java application that runs. And what it does is it goes and searches the domain controller, or LDAP, okay? It'll go and search LDAP and allows you to query LDAP and say, look, it's got a little GUI. And so you go down and you click, like here, I clicked on a user called SALUITER. It tells me their CN. It tells me their object class. It tells me, it obviously doesn't tell you the password there. It's usually encrypted. It tells you, what groups they belong to. All of the information that I needed to get the connection. And so I would use this and pull it in. So I thought it was kind of funny that they didn't know any of this information, yet they were managing it. That's why you'll hear some of us Unix folks make fun of the Windows administration folks, because all they know is the GUI. They don't know how it works behind the scenes, whereas a Unix administrator usually knows how everything integrates behind the scenes, because we're literally command lines. We see the directories, all the config files, all the other ones see is a GUI. And by the way, I've been a Windows administrator for about 10 years. I did a Windows administration, but but that's why sometimes they get made fun of. But you can see that it supports LDAP. Here, let me decrease it now. It supports LDAP, and then once again, here's exactly what it looks like. This is what it looks like over here. And hold on, I gotta get it into position. Let's find it. Yeah, this is what it looks like. When you log in, you have to log into the thing. Once you log in, it'll give you the little menu over here, and then you can start clicking on it and drill down into it and get pretty much all the information you want. So this is the one I would use, was JExplorer. Okay. Let's see. Are they still developing it? It doesn't look like it. The last version was 2013. So, and I've used it since then. So it's still, it still works. Okay. But there are other tools out there, folks. There are other tools out there that will go out there and pull the information. The thing I didn't like about LDAP search, okay, is you have to know the exact command line parameters. Whereas with, at least this JExplorer, it would actually put it into a menuing system that you could just go in and click down through the menuing system. I didn't have to have an exact LDAP search string. I started using this initially. I'm like, okay, this is cumbersome. How many searches do I have to do before I can get? And what it was, they had put it into a weird group, the account in a different group that they didn't tell me. It was in this other group. And so when I was trying to just search regular accounts, it was in a total different group. I was trying to search like users. As you can see right here, you have this users. Well, that's a group, okay? And so I was searching basically the users, and it wasn't in there. And I'm like, and finally when I Googled, I found JExplorer and loaded it up, and I instantly found the user, because you could go and search through this. And I was like, okay, this is great. I said, oh, it's in this group. Oh, yeah, we put it in this group. I'm like, well, thanks for letting me know. Excellent web-based tools are available also for managing LDAP, like PHP LDAP admin. LDAP is well supported. It's been around for several years now, and Microsoft's Active Directory is based on LDAP. Here's that LDAP search. And as you can see, look, see how these parameters here? Here's the host you're searching. This is the LDAP host. That's what the H is. This is the port. But then look, you've got to know CN equals Trent, CN equals users. I was using users, and I should have been using a totally different, instead of users, okay, they were in a, a totally different group, okay. Domain controller is boulder.atrust.com, okay. So first off, you've got to type in, okay, I want to do a search. You got to put in who you are to authenticate yourself. And then you put in what you want to search for. Oh, I want to search for, look, I'm searching all of users for Ned. Well, Ned might not be in users. They could have called it something else. And that's why I use JExplorer. Now, once you do an LDAP search, it does, notice you don't put your password up here. It does say, hey, enter your password. So you're saying, hey, I'm Trent of users in the boulder.atrust.com domain. And I want to search for a user called Ned. And here's Ned. Gives us that information. And here, look at this, object class top, object class person, object class organizational person, object class user. We don't put these in. A lot of these are in by default. Usually now, if we wanted to give Ned here a different group, well, we could. We could give them a, see where it says member of, enterprise admins. So we could put them in the enterprise admins group, okay? Give them a different membership. So, and this is all the information it pulled about Ned. You want to know about LDAP? Well, there's tons of RFCs, and there are books, big, thick books on LDAP. Now, another way that Unix systems can share information similar to LDAP is called NIS, Network Information Service. I haven't seen this used a lot, but I set up a lot of these back in the day, before pre-LDAP. A process would run called YPserve. That would be a server, similar to an LDAP server, but similar to a server. And on each of the Unix clients, you would want to run YPbind. And what it did was it enabled those clients to access the server and read data from it. What kind of data? Well, data like basically host files, group files, password files, shadow files. All of those files in ITSC, NIS would propagate them around the Unix network. And we used this extensively back in the day, okay, until LDAP came out. And then we started moving stuff to LDAP, and NIS kind of fizzled. You could do a YPXfer, which would download the current version. You had these mapping files that would contain the information. We could do a YPCat to see the NIS maps. A YP password if we wanted to globally change our password around the network. Yeah, we would basically, we wouldn't use local password files. We would basically use NIS. And it would propagate then using this YPbind on clients, running and connecting to the YP server. Remember that nsswitch.conf file? Well, that also can tell it, hey, where do you want to go for a password? LDAP. And NIS would be also, before we had LDAP, we would have NIS right here as well. And that's in that nsswitch.conf file. A compat mode would tell it to do files and NIS. Okay, that was a quick chapter, folks, to just discuss single sign-on. Pretty much everything's LDAP now. I don't know, you might see NIS in some older environments, okay? But it's a way to do single sign-on. Now, how many of y'all have logged in to, say, some site out there and it says use your Google account, use your Facebook account? How many of y'all have done that before? Answer yes in the chat session. Okay. Well, there are external companies as well, like OpenID as an example. It was a way, to allow other companies for you to authenticate through in a single sign-on fashion. And that is the external internet side of the house, where you're able to log into a site and then they're sending a pass-through over to that site to allow you to use your Facebook or your Google email account. Okay. So yeah, ACC uses Okta. So you have the OpenID Foundation. That's what that OpenID is. Okay. And by the way, there's thick books. We can't in this class, go through every single thing that you can set up on a Unix system, but you need to know what you can set up on a Unix system. I could teach a whole class on single sign-on because it's not just LDAP is complicated, but there are other types of authentication systems, like SiteMinder as an example. That is run by Broadcom. It is a whole application that has an LDAP backend, and it also has RSA servers for utilizing key type exchange for authentication. So there are a ton of different single sign-on environments and systems. For the most part, large companies use Windows Active Directory for single sign-on, and the Unix systems will also go talk to Windows Active Directory as well. Okay. Give me 2 seconds here. Chapter 18, a little longer chapter. We'll see if we can get through most of this. I may pause it in the middle. So electronic mail, once again, this is a course in itself. So some of these things that we discuss in this class could literally be an entire course. Okay. Electronic mail, been around a long time. Okay. You have different types of mail systems. For example, on the Unix side, you have SendMail. SendMail has been around for years, and this is when I set up mail servers, I used SendMail on the Unix side. However, on the Windows side, you have Microsoft Exchange, and I've set up that as well. You have XM and Postfix. Once again, Unix and Linux, and this one is Windows open source and Postfix. I have not set up XM and Postfix. I've set up SendMail on the Unix side and Microsoft Exchange on the Windows side. Most and all of these mail systems have key components. Okay, key components. For example, you have a user agent, which can be Outlook if it's an Exchange server, or it could be a GUI of some type, or on the Unix side, the bin mail, I can type in mail and it'll send mail out based on just a single command line. I could mail some file out to myself. But whatever that client is, okay, or in this case, that user agent, which is basically a client, connecting up to a SendMail server. That SendMail server does a couple of things. It also includes this. A SendMail server includes a transport agent and a submission agent. Okay, meaning that something's listening for incoming mail, and then what it is, and by the way, the submission agent right here you're looking for is where a client of some type would connect into your mail server, and then it would submit the mail over using port 25. Now, port 25, okay, is a SMTP port, and mail servers use SMTP to transfer from one mail server to another mail server. When that mail server gets there, it usually puts it into a queue to be analyzed, okay? And you have then a delivery agent on the system that delivers it to either a flat file, or in this case, they're showing a message store. Message store is Microsoft Exchange. It's a database. Microsoft Exchange has an Exchange database that allows us to keep all of our mail in it, although we can put limits as an administrator, okay? And then here you have an access agent of some type that would either pull the mail down locally or access it. For a message store, it's usually Outlook. For flat files, we might use IMAP or POP. So a mail system has these distinct components. A user agent that lets users read and compose mail. A submission agent that accepts outgoing mail, grooms it, and submits it to the transport system. A mail transport agent routes messages from one server to another server. Could be over the internet or could even be local in your company. And a delivery agent that places the message in a local message store. Could be a user's mailbox or a database. Mailbox usually means a flat file. And then an optional access agent that connects the user agent to the message store. An access agent would be something that really kind of, accesses this database. Okay. You can also have accessing flat files with something like POP or IMAP. These would be two. We would run these daemons on our mail server, and then we would be able to access them with our client. So, for example, with Outlook, Outlook can use POP and IMAP, but Microsoft Outlook can also access a message store on an Exchange server using MAPI protocol. Okay. And then, of course, there's bin mail. This is a command line command on Unix. I could type in mail and access those flat files that are meant for me. MSA, mail submission agent. It's used for outgoing mail. It grooms it and submits it to transport. The mail transport agent uses port 25. This is a well-known port for simple mail transfer protocol. And nowadays it's extended. Why extended? Well, you had all that HTML that you can embed in the email to make it look pretty. Okay. Whenever we talk SMTP or ESMTP, that is what we're using to transfer from mail server to mail server. Now, the mail transport agent does a lot of different things. One receives email from remote servers, understands the recipient address. Okay, and by that I mean the recipient address could be, let's say, your name, first initial, last name, first name, last name, and sometimes we have aliases. We put aliases in case somebody makes a mistake, and instead of sending it to James.Wade, they send it to JWade. We can redirect the addresses using that mail aliases. We can rewrite the address. We can forward messages to the next responsible mail server or pass it in. One of the other things is when we rewrite an address, we can actually, and I'm going to show you here in a minute, we can actually change the name of the mail server. Now, why would we want to do that? Well, here we go. So most companies do something like this. Here's the internet. Here's a firewall. Once again, opening up specific ports. Here's another firewall. And here's my DMZ. Remember, we drew this just, not last chapter, but the one before that. And here's my mail server. But here's the thing, folks. This would be an internet-facing mail server where companies on the internet, here we go, here's these companies on the internet, all these different companies, and they are sending mail to our external mail server. Now, here's the thing. Inside my company, folks, I have another mail server. Here it is. And by the way, this is what I set this exact configuration up. It was an Exchange server, Microsoft Exchange. And this mail server was UNIX using SendMail. Now, mail servers do more than just deliver mail. Okay. Mail servers actually can scan the mail, check it for viruses and malware. They can also check to see, okay, you see on the outside out here, this is coming from different mail servers. I can check, are you legit? Meaning this is coming from a real mail server from some domain. I can also check a list of bad mail servers. So I can do this as well. I can go out here with my internal system and I can say, okay, that's not a good color. It's not bright enough. How about we use yellow? Okay, let me go out here and check. So I can do two things. I can say, hey, are you legit? Let me check your DNS to see if you're a real DNS server for this company. The answer is no, I dropped the mail. Or I can go out and check a list. Hey, do you know if there's any bad email? There's organizations out there that keep these lists. You know any bad email like spam or something like that that comes from this email server? And if we do, we drop it. What our internal mail server will do then is it'll send that mail to the Exchange server. The Exchange server also has virus and malware software. Now, it's not going to scan really and see, oh, is this coming from a legit email server? Because we're forwarding it from here. Now, we can go do some security and say we're only going to accept mail from this server right here. That's it. It comes from there. Awesome. Now, I'm over here. I got my mail, I'm reading it, and I do a reply. As I do that reply, here it goes. It's not going to send it out to the internet. It's going to send it right here. That's not a very good color either. Let's go with a brighter one. It's going to send it right over here. Now, remember it just said up here, it'll rewrite the address. Well, this mail server down here is going to see it coming from this mail server. And that is what the mail server name is going to be. Okay. It's going to be J Wade from exchange.mycom.company. Well, what this has the ability to do is rewrite it with my bind. And it's going to say, hey, I'm coming from mail.mycompany.com. It's going to say it's coming from the mail server that's identified on the internet. And then once it rewrites the name, out it goes. Okay, out it goes. So the other thing that we did is on our mail server here, that was internet facing, we actually used McAfee's software to scan all the email. So we had McAfee's virus software and malware, and it would scan all the incoming email. Once it said it was okay, it would send it to the Exchange server. The Exchange server, you know what it did? We had Norton running over this. So we had two virus companies, two vendors, and we were scanning our email as well on this one. There's a lot of different security that you can do on these mail servers to ensure that you don't get viruses, malware, as well as, other type of issues. Spam, as an example. The local delivery agents filter email before delivery. Procmail places email in the message store. Now, Procmail is a program, and I haven't used MailDrop. I have used Procmail. What we have the ability to do is, and if we go back here, hold on, is I can have right over here, I can have a Procmail server, and I can forward some email going to specific mailboxes to the Procmail server. Here's what we did. we had a list of our customers' email addresses. So if we wanted a customer to be able to automatically open up a ticket that we would assign to the service desk, what we would do is we would get an email from a customer that would come to a specific email address, and we would ship it to ProcMail, which would see if, hey, is this a legit? So this is something ProcMail can do. So here we come. Here's our customer. We want our customers to be happy. Here's a hacker. And here comes emails from both of them. Where's it coming to? Well, it is going to our DMZ mail server. Our DMZ mail server. This, and it's coming to support at mycompany.com. Okay, I ran out of space, but mycompany.com. So it hits that email address, and the mail server looks at it, and it says, oh, send this email over to our proc server. On this proc server, we have, and I'm going to use we have a list of customer email addresses. So in comes the hacker. Proc server checks. That's not a customer. Goodbye. In comes the customer's email. In comes the customer's email. It's sent to the proc server. Oh, yep, it is a customer. Legit. Okay, send this over to our ticketing system and open a ticket up. Okay, and I configured basically ProcMail for the company, and I would send it automatically over to a ticketing system. But it would only look for customer email addresses. It would pick that out of the to field of the email, and that's what ProcMail does. It has the ability that you can read the email and then run some scripts of some type. That's what ProcMail does. Okay. Message stores traditionally stored in a mailbox or mail directory like var mail usernames. These are flat files or databases. And I would not, just me, if I was writing this, would not call this a message store. To me, this is not a message store. This is a flat file. I'm probably the one that put the flat file there. Databases are message stores. Okay. Databases are message stores. Here, a message store. Yeah. Okay. If you want to walk a fine line, but to me, when you say a store, that's a database of some type. Okay. A mailbox to me is a flat file. You can access utilizing IMAP or POP. This pops the information in the flat files. It will also go and interface with a database, but you have to have software enabled that will let you use these two protocols and then still pop down Microsoft Exchange messages. What's the difference between IMAP and POP? Well, POP pops the mail down and copies it to your PC. MAP leaves it up on the server. IMAP does. MAPI is the Microsoft Exchange protocol. It would keep the messages in the message store in the Exchange database, and you would use a program like Outlook that runs MAPI protocol. Whenever we send out a mail message, it has three distinct parts. The envelope, which is basically has the to and from fields. The headers, which basically has the date and time it was sent. The mail servers it passed through, and the destination of where it came from. The destination of the message and where it came from. So the from and to. And then the body of the message. It could be in plain text or be in HTML. So how many of y'all know that for your email, you can always take apart or go in and look at all of this information, this mail header information? Answer yes in the chat session or no. Did you know that you could actually look at your email and, in Google or whatever you want to, let's go, hold on, let me pick one of my emails and give me 2 seconds. And I've always got to look for it in Google Chrome. There we go. Okay, so here is my email, james.wade@austin.cc. I picked a mail, an advertisement, welcome to Workday, getting started, da-da-da-da. Now, first off, if I click up here, okay, in the to field, it shows me a little bit of information, but not much. But if I go click here and say, hey, show me the original, watch this. Look at all of this. Here's the message ID. Here's where it was created. Notice, look at this. It's telling me that, who it's to, the subject. But look down here. Notice it says delivered to James Wade at austincc.edu, received by, and look, you start getting into information. Now, some of this is encryption. This is these are these keys that particularly are there showing us, where that it is indeed a it's their seat. It's their I'll spit it out here in a minute. A little early still. It's their seal here, but basically this is usually a certificate that shows it's a legitimate email server. Okay. But when you start looking, look at this. It shows me the pass it went through, received, Google. Okay. Let's see if we can find down below their mail server from where it came from. Look at this, received from, and here's a IP address right here, and by. So here's another IP address. They're just telling you where it was, received from and who received it, what mail server did. And all up in these threads, look at this, received from ccm168.constantcontact.com. Okay, don't know what that one is. By, and look at this, mx.google.com. Remember the MX record that we just talked about? Well, there's the MX record. And so this is the full information. And look, it's not even formatted well. It's actually showing me the HTML in the document. All I did was I went to one of my email messages and clicked on show original to get all of the header information right here and actually see the HTML format. Okay. This is a HTML document. See, look at this, content, text plain, content, but when you start getting down here, look at this. There it says content type HTML. Okay. You can pull that up from any mail. There will be, most clients give you the ability to see this header information. Okay. Here you can see, look at this, mx.google.com, exactly what you saw a minute ago. Received from mail.schweikert.ch. That's the mail server. There's the IP address of it. So it can show you what mail servers it's gone through. And look at this, extended SMTP shows you the protocol as well. Okay, so all of this information shows you the trail that it went to get to you, how many mail servers it went to. And then here, headers, again, truncated from a spam message, received, google.com, neither permitted nor denied by best guess record. See, one of the things that DNS can, that our mail servers can do is they can validate that mail is actually coming from a legitimate mail server that's out there, not spoofed by somebody. So here we go. Here's how we traverse. Once again, you have a user agent. That user agent connects to a mail server, sends the mail, and over here, you have other people checking their email. But when we look at that communication between the mail servers, it is SMTP. Okay, SMTP. These user agents could be Outlook, Elm, Mozilla Thunderbird, an iPhone mail client, Gmail. Mail servers, well, mailboxes contain incoming messages for users. There's a message queue. Usually when you send a message, it goes into a wait list, a queue, because there might be other mails ahead of it. It analyzes the mail as well. Is this coming from a legitimate user in my organization? And if it is legit, it sends it out across the internet from mail server. And where does it get? What mail server do I send it to? Well, it looks at that domain name in the to field. So in other words, if I have, let's say I have to jwade at myco.company. Well, before this mail server here can send it to, let's say, this mail server here, what it's going to do is it's going to go out and talk to a DNS server for myco.com. And it's going to say, hey, give me your MX record. What's your mail server? And once it gets that IP address of myco.com, well, it's going to send your mail off to that mail server over port 25. Okay? That's why those MX records are there. So here we go. Alice uses some type of user agent to compose a message to Bob. Alice sends that message to her mail server. And then behind the scenes, the mail server's going, oh, okay, someschool.edu. Let me go talk to someschool.edu's DNS server, and says, what's your MX record? I need to send a mail message to your mail server. That comes back and it says, great, let me send it to your mail server. Okay. Sends it over port 25. And once it gets here, it says, oh, who does this go to? Oh, it goes to Bob. I know Bob. Let me put it in Bob's mailbox. Now, that could be a flat file or it could be a message store. And then Bob over here gets into his user agent, could be POP, could be IMAP, could be Outlook, to access the mail server and access his message. Once again, when we look at a mail, okay, you have that header and then you have a body. And we looked at that. We looked and saw the header, which can be huge. It has the to, the from, the subject, and it has a lot of other information. But just a basic mail message has a header that has to, from, and the subject, and then the body of the message. SMTP is used to deliver the messages. And for the user to get them, well, they can use different protocols. They could use POP, which is called Post Office Protocol. They could use IMAP, which means Internet Mail Access Protocol. And of course, you can have HTTP driven, which is Gmail, Hotmail, Yahoo Mail. POP, they're just showing you an example of what POP does. It's a protocol. You can actually log in and via using Telnet. Okay. Don't really want to do that because it's unencrypted, but you could. And notice you can type in commands. Hey, I'm user Bob. Okay. My password is hungry. Okay. List. Oh, you have two emails. First email is 498 and 912. they're just giving the mail message a number. Okay. And then here, retrieve message 1, and it would show you. This is if you wanted to access via a command line your mail. It will work. Most people don't do this. What you do is you pop your email down. POP3 does use encrypted as well, different port, but you basically can pull it down using encryption and pull it down to your mailbox like an Outlook. That's what I used to do. And then delete 1, retrieve 2, read it, delete 2, and then quit. So POP3 and IMAP. The previous example used download and delete. And for the most part, that's how POP3 was meant. It was meant for people to grab the email off the email server and have it on their local computer. He can't reread it or get it again. It's on his local computer. It's a download and keep. IMAP, on the other hand, they had, when we started doing a lot of traveling or moving from location to location, and people wanted to read their email, well, it's not very good if it's on your desktop, right? So they came out with IMAP, which would keep all messages on the server. It allows you to organize them as well in folders, and it keeps the state session across it. The names of the folders and the mappings between message IDs and the folder names, meaning everything stayed on the server and I could access it. Once again, I could use Outlook, and Outlook actually allows you to connect multiple mail accounts. I could have one account that uses POP because that particular company or organization doesn't want to store anybody's email. I could have another one that uses IMAP because they do want you to store everything on the server. And I could connect to an Exchange server using basically MAPI protocol. And MAPI stores everything in a database, and you just leave it online in a database. Although with Exchange and Outlook, you could also have it keep a local file on your system. And then you had a filter that would send all the messages to the local file. SMT protocol. These are how messages move around the internet. Now extended SMTP protocol, Simple Mail Transport Protocol. It's TCP port 25, been around for a long time. What does it do? Well, a user agent to mail submission agent, or a transport agent, meaning it can transmit the agent from one server to another server. It's a mail submission agent to the transport agent as it starts its delivery journey, meaning it'll store the messages until they're ready to go. Okay. It also has the ability to have an antivirus or anti-spam scanner to scan all incoming and outgoing email. And it has the ability to forward from one site to another. And then, of course, depending on, if that mail is actually stored on the mail server or in a database, it has the ability to deliver that to locally. So once again, it can send it to other mail servers. It can queue up waiting for stuff to come in and send them on their way. It can basically scan for viruses or malware, incoming and outgoing. It can forward it to another server. Now, why would we do that? Well, some huge companies have multiple mail servers, and each mail server has a different user. So you usually have one mail server that's incoming, like the UNIX DMZ one, and then it would have a mail aliases file that would forward that email to the correct internal email server. Okay. Uses TCP to reliably transfer email, meaning it's doing that three-way handshake. It is doing retransmits if need be. It's validating all of the communication using sequence and acknowledgement numbers. Okay, that is standard TCP. So it does the handshake, three-way handshake, transfers the message, and closes the connection once those messages have been transferred. It does have specific commands, specific responses with SMTP protocol. here are some of the SMTP protocol commands. Hello, host name, or hello. Hey, I got some mail, needs to go here, and it could send it. Now, folks, we used to do this to validate our internal mail servers. We would log into it, type in hello, this is the domain name. I'm sending mail from this person to this person. We would actually enter the email. See, you enter a data command, and then it says enter mail with a dot by itself. Do you like ketchup? How about pickles? Dot, and the message is delivered. We used to test our mail servers out by actually logging in to SMTP, typing in manual commands like this, and sending it on its way. Now, mail servers, as you can imagine, have specific messages. And how are we doing here on time? We're doing good. I may stop at, let's see, our class gets out 12:15. I'm probably going to stop here in about 10 minutes, folks. We may not finish this one. It's a long slide set for SMTP. But these are some of the messages. Mailbox is full. Yes, one of the things that we would do is we would set the size of a user's mailbox, okay, requiring them to do a little bit of management. And if that mailbox was full, it would answer back, hey, it's full, meaning I am not going to deliver your mail message. Or maybe it was disabled because the user no longer works here. Maybe the message was too long. Or another one is if you were getting an attachment, is the attachment too big? A lot of times we would only allow a 10 megabit attachment because we didn't want somebody receiving like a gig file or something like that. Crazy stuff. How about it's sending it to too many recipients? Like this looks like a spam. It's going to everybody in the company. Nope. Delivery not authorized. Or it's a site policy violation. So as I said, we could do telnet, the SNMP server, the SMTP server name, and port 25. By the way, this telnet and putting a port is a key way that we also test for firewall ports. We can also set up some authentication with SMTP. Okay. This is normally not done on the external email server. We normally do it on internal. For example, remember how I had a DMZ email server going to my Exchange server? Well, I could set up authentication between the two so that only an authenticated server could send messages inside the company. So mail system design, servers for incoming and outgoing for large sites, filtering for spam. We want to make sure we set up some filtering for spam and viruses before messages can come into our site. And then we want to also filter before sending messages out to make sure one of our users isn't sending messages to everybody in our company or outside our company because they got a virus on there. So we can basically scan both incoming and outgoing email for virus or malware. For busy sites, a backup mail server for outgoing mail. Journaling and archiving for legal purposes. Usually we use backups for this as well. A mail home for a user at a physical site. We could use IMAP or POP for PCs, Macs, cell phones, or we could use an Exchange server. Mail servers have at least 5 functions: to accept outgoing mail, to receive incoming mail, to filter mail for spam, viruses, and malware, to deliver mail to users' inboxes, and allow the users to access their mail with IMAP, POP, some web-based GUI that we have, or by utilizing something like an Exchange server and Outlook. We can have 2 types of mail servers, and this is exactly what I was talking about in my diagram earlier. You have a DMZ. The DMZ is for filtering incoming and outgoing messages to the internet. And then we can have our internal network, another mail server. Could even be a different type of mail server. Instead of, running SendMail, which is the UNIX mail server software, we could run Microsoft Exchange inside and send mail for DMZ. Anytime we have email coming, though, from something like the internet, we want to check these things. So we can set the mail server up that it does this. The sender's site is not on the blacklist. The sender's SPF record is okay. The local recipients are valid. Is the message signed? Remember that I mentioned that certificate? Well, we can have a DKIM signature that has to be verified. That signature or cert is actually in the DNS server of the person sending it, and you can go and validate it. You want to also check malware or viruses aren't embedded, and it's not spam. Yep, we can scan for spam too. Internal mail servers in our network should tell, and I'm going to say this, folks, all of the other stuff, okay? That you want to check the routes and where the mail message is going. We want to check the LDAP database to see that, well, you know, is that mail going to the right mail server? Because we might have multiple mail servers. And they can check to make sure that, you know, do we have the right mail server going out as well? And then we also want to still filter for viruses and spam. Why? Well, because somebody could get a virus on their computer from a USB, from a program they loaded, and all of a sudden it goes and tries to use the mail server to spit out spam or, you know, information. So we still are going to scan for all of that, whether it's internal or external. So every mail server usually has what's called a mail aliases. It allows the mail to be routed to different places based on a name. For example, james.wade@mydomain.com or jkwade@mydomain.com or jadawade@mydomain.com. Well, usually you only have the name is one name. So I might have james.wade@mydomain.com. That's what my real mailbox is. But if somebody accidentally sends it to jkwade or j.wade, well, I can have an alias that will send it to where it's going. I can also have groups that get mail. So here, look, local name. This could be my james.wade. And then here, and here I can have multiple recipients as well. I should have said a group. I can have a group here, admins, and then it would have all the admins listed. I can also have, you know, multiple names. Here I could have j.wade goes to james.wade. You know, jk wade goes to james.wade. Okay. So here we go. Here's an example of a config file for mail aliases. And so in addition, a list of users, aliases can refer to a file containing a list of addresses, a file which the message should be appended, or a command. Yeah, in that mail aliases, we can tell it to execute a command. Okay, an actual command. So here, mailer-daemon would go to postmaster. And look at this, postmaster would send it to dev null. By default, most mail servers have what's called a postmaster. And that postmaster account gets a lot of spam. And so a lot of times we'll set it to dev null to tell it just to go nowhere. Here, look at this, David, and then David at somewhereelse.edu. This could be another mail server that David account is on. Here's auto FTP, and notice that I'm going to execute user local bin FTP server. I can pipe any email going to auto FTP to the FTP server, an actual command. Okay. And then here is another example of a mail aliases file. Okay. You know, I could send it to basically, you know, these are all the mail accounts. So bin, daemon, admin, and abuse goes to root. Junk goes to dev null. Root goes to Ned. Okay, so Ned gets all these root emails. So mail alias, there are packages that automate it. Mailman written in Python, Simpa written in Perl. I've never used these packages. I've always just edited it myself. And both packages have web interface. I'm going to try and get folks to the section where they start talking about mail server software. And then we'll stop there and we'll take a little break and then do the lab. So considerations before implementing content scanning, like spam and malware. Where to scan in the DMZ or internal network? Both. When to scan, at the initial connection or after the message is accepted? Both. In what order to scan? What to do with virus and spam message you identify? Delete. Okay. Now, why do I say at the initial connection or after a message is accepted? Because there is a way, folks, that you can, let's say you've got a virus on your system. Well, what we do is we would scan everybody's mailbox on Exchange. And it was constantly 24/7 scanning everybody's mailbox, looking for viruses. Because somebody could be writing a message, but not sending it yet, storing it as a draft, okay? And you want to scan. After a message is accepted, well, you don't know if it passes the scanner initially, and then somebody gets it, they open it up, turns out the scanner missed it a little bit, but as soon as it opened up, it recognizes it as a virus. And so then we would have constantly scanning people's mailboxes. We suggest the following order of operations. Checking RFC compliance. What they're talking about is mail coming in. Check the compliance of the sender's SMTP implementation. This is where they're checking to see, is it coming from legitimate source on the internet? They're querying their SMTP server as well as their DNS to make sure it is a legitimate email server. Verify the existence of a local recipient. Is it going to somebody in our company? Also, we can look and see if there are any blacklists on the IP address on that mail server that it's coming from. We can check the reputation. Is this coming from a mail server that's normally known for spam? We could also check DNS to see if they have any, basically domain keys. That's what this stands for, domain keys. Okay. Or we could check their policy framework. In other words, their MX records. Here we're just validating it's coming from a legit company. And then here, spam, filtering, and scan. So really what you're doing is if you look at this, what they're doing, first they're looking to see, does the SMTP mail message, is it legitimate format? Okay, that's what they mean by RFC compliance. Is it a legitimate format? Then they're just checking, is it going to somebody in our company? Now let's go check the IP list of where it's coming from. Is it a legitimate company? Now let's check, and usually both of these two are an external organization. It's not the company itself. They're checking an external organization to see if their mail server has been blacklisted or to see if what the reputation of mail coming from that site. Is it spam, as an example? Then they're going to contact that site and see, okay, do you have any domain keys here that we can ensure you're legit? And then it's also checking, and what about your MX records? Is this really coming from one of your mail servers? And then we check for spam. So here we are, spam filtering, gray listing, temporary deferrals. This is compliance checking. Is the message legitimate? Format, is SMTP formatted correctly? Spam assassin is a pattern matching spam recognition tools. Blacklist is a known bad guys in the spam world, often DNS based. Whitelist, known to the good guys to avoid false positives. Mail filters that scan the header and the body of the message. SPF, sender policy framework, that identifies the MX records of that company. And then domain keys identified mail is a crypto signature for the email message. That's usually in DNS. And then author domain signing practice, DNS records declare signing policies for any subdomains. And then finally, we can have something like Amavista New, which is or mail scanner, which looks at antivirus and anti-spam filter. Whitelist are DNS reputation lists. You can set it, and here's one right here, dnswl.org. Rates domains as high, medium, low. And then in your mail server, you can say, okay, we're going to accept low or medium. They recommend you omit some of your usual mail scanning based on this rating in the list. Okay. We could skip blacklisting. We could skip spam filtering with ratings of high or medium. We could skip, every domain with a rating that's been blacklisted or gray listed. And then we could, but never skip virus scanning. Mail scanner written in Perl recognizes spam, viruses, and phishing. Supports 25 external tools like ClamAV, which is antivirus, Spam Assassin anti-spam, and Scam Nailer anti-phishing. Amavist New, written in Perl, interfaces between your message transfer agents, has ClamAV, Spam Assassin, and other tools. Lots of them. Okay, we're on 36. I am going to stop this. This is where we get into the different mail servers and configuration files. Give me 2 seconds. And hold on. Okay, I'm going to get rid of 17. Let me get rid of this. I'll log out. Let me clean up just a second here. So mail servers, I'm going to put start here, and we will finish this up next class. And just if you look at what we're going to cover, different mail server configurations of send mail. About 25 slides left. Let's go over the schedule here really quick. So today was 16, 17, and 18. And I figure 18 was going to be half just because it's a lot to cover. Where you should be at in class, well, you should be done with chapters 14 and 15 quiz. It was due today. You should be done with all of the scripting. As of today, and the rest of the labs are going to be basically loading software. It's going to be loading software. So we are going to now, lab 7 through 15, it's going to be dealing with Unix systems. You're going to create using VMware Unix systems. No more scripting. That doesn't mean we're not going to modify configuration files with VI, but for right now, there will be scripting is done. So if you're not done with labs 1 through 6, folks, or you're not up to chapters 14 and 15, well, you are behind in class. And you're going to want to get caught up. The more you get behind, the harder it gets. Okay, the harder it gets. Okay, let's go take a look here really quick. Give me 2 seconds. I'll pull this up. Okay, so we covered chapters 1 through 15 already from last week. And if you remember, I told you what's coming up next Saturday, you should have the midterm done. The midterm is over chapters 1 through 15, and we're up in 16, 17, and 18. So we've gone over all the chapters. You should be done with 1 through 15 quizzes because this midterm is based off the same quiz bank. Chapters 1 through 15, it's 100 questions, folks. 100 questions. Now, you have to use the lockdown browser. And with the lockdown browser, it is not monitored or, it's literally, you can do this quiz. So you just have to use the lockdown browser. Okay. It's not audited or, you don't have to have anybody watching you on a camera. Also, If you want to, this doesn't prevent you from pulling another device and logging into that other device. And basically, when you log into the other device, there's nothing preventing you from, let's say, using another device to use the quiz as references, or using the PowerPoint displays, presentations, PowerPoints as reference. It is not a timed test. You can take it as long as you want. And some people want to pause in the middle, but what they do is they basically reboot their computer and then they get back in it later. Now, if you accidentally submit, let's say 40, and you answer 40 questions and you accidentally do a submit, all I can do is clear the attempt. You have to log in, and once I clear it, you'll have to redo the 100 questions. So any questions over the midterm or the schedule? Once again, midterm is due next Saturday by midnight. You should have 1 through 15 quizzes done already. And you should have up to Lab 6 done already. And the midterm is now due this Saturday. You have a week to do it, basically. Any questions on the schedule or on the midterm? Answer no in the chat session, or feel free to ask a question. Okay, give me 2 seconds here. Okay, let's look over the next lab. And let me pull this up. I had no questions. Awesome. I'm going to close that. Oops, let me bring this down again. So our lab assignment today is Lab 7. Okay, Lab 7. Okay, and you will notice it says install CentOS. I give you these lab instructions. They're fairly detailed. If we pull those up, you'll notice here it says, hey, create a virtual machine. Okay. And then you're going to pick the ISO. Okay. So there is a minor change to this lab. I'm going to show you what it is. That minus change to the lab is the security settings when you load the software. Right down here. And I haven't really changed it. They keep changing this like every single time. See where it says right here, select standard system security protocol, standard system security protocol. You don't have to worry about this section. They keep changing it in every version. Now they don't even have anything. You go here and it's empty. Okay. And then you install the software. Now, here's another thing you have to be careful of. I tell you what to install. See, it says right here, click on Server with GUI and Performance Tools and KDE. Now, sometimes I can't show all of this because see, look how there's stuff below it. So you need to read. Right here it says, hey, install KDE, DNS, and Performance Tools. I will always tell you, I just may not show everything in this GUI right here. And you got to click on the right one. See, it says Server with GUI. If I don't see a GUI, well, then I assume you didn't follow the instructions. Okay. Now, if you look here, it tells you install CentOS version 7 to VMware. You click on this, and I'm going to show you right here. This is for version 7. There is a version 8 out there that you can play around with, but that's not the lab requirement. So if I click on this, see how it has these mirror sites? And let's see, DFW, that's a close one. Click on it. And then I tell you to install, see this 4 gig, not the everything, but you click right here, this DVD 2009, and right here, this 4 gig connection. And the one that, not a connection, but it's the 4 gig. You don't need to do the everything. And it is an ISO. And I even tell you in the instructions on Blackboard, we go to Blackboard, I give you the file name. Look at this. It says, let's use version 7, CentOS 7, ISO X64, and see the file listed right here? Size is 4 gigs, CentOS 7, X64, DVD 2009. Takes a little bit to download it because it's a 4 gig file, but that's what you're looking for. Now, I already downloaded it to my system. And give me 2 seconds. I'm going to move it. Let's go cut. UNIX 2 and paste. And give me 2 seconds here. It says 10 seconds to do this. So you're going to download this file. You want to make sure it is indeed this file and it's got this name. VMware. Let me bring VMware up. VMware uses an ISO. Does everybody know what an ISO extension is? Answer yes in the chat session or no. How many of y'all have heard of an ISO? Okay, 2 or 3 or 4 no's. So ISO is an international organization. That's not what an ISO is. Where's it at? Where's it at? ISO is an extension that they use for DVD type formats. Okay, it is usually a bootable device. Okay, it is basically considered a optical disc image. Okay, in an ISO format. In other words, like a CD or a DVD. Well, that is what an ISO is. Okay, I was looking for, because even me, folks, I often, don't remember because I've been working for it for so long. I'm using just the abbreviations, and so a lot of folks are like, okay, what's that abbreviation mean? When you start out, later on, you forget what that abbreviation is. And when you, when you forget what it is, you just use that name. You know what it does, okay? I think it's funny. So an ISO image is basically just optical media. It's like a CD, a DVD, or a Blu-ray. It's a way that you took here we go. I got one right here. What is this one? Hands-on ethical hacking. So it's a way that you take a DVD, okay, and you copy it to a single file. So instead of on this disk, it's a single file, and it's a .iso extension, okay, a .ios extension. I can actually mount an ISO with Windows. I could tell it to mount it, but we don't want to. You want to be careful that you don't mount it. Okay, let's take a look. So here is our directory, and here's the .iso extension. This also tells our operating system, hey, we could mount it. If I right-click on this, I could click on mount. I can also, with a DVD writer, I can also burn the image to a DVD. I could get a blank one. As a matter of fact, look here. I actually have sitting on my little counter here, because sometimes I do burn one, but I've actually got a 4.7 gig right here. So I could take that ISO that you see right here. By the way, I'm showing this on my camera. And I could basically burn this onto a optical disc, okay? And I could pop it into my DVD drive, okay? This is a 4.7 gig DVD. This says 16X. I think that's probably just to trick you because it really depends upon the drive. But, you know, see, I got a few of these that I keep around the house in case I want to burn a DVD. You know, I don't often do it, but once again, you do it with that ISO image. There's plenty of, here you go. Here's a quick Google. There's plenty of places. I'll actually give this to you, this link. I don't know how updated it is. 2018. That's pretty up to date. That talks about, well, how do you use an ISO file? You know, well, we could mount it. Look, there's even a nice little video. So for those of you that answered no, that is what an ISO is. See, I can burn the disk image. I can mount it. We don't want to do any of that, okay? What we're going to do is download it. And then one of the things we do is we can boot off of it with VMware, okay? We can boot off of it. Any questions on what an ISO file is? Any questions? Answer no in the chat session or feel free to ask a question. So hopefully those of you that answered no, you know what it is now. So what you're going to do is you're going to click on this link and you're going to download this 4 gig file right here. CentOS 7 x86 64 DVD 2009 ISO. Once you have it downloaded, there it is. What are we going to do next? Well, now we're going to go to VMware. Okay. And hold on, and I'll pull VMware up. Oh, by the way, you may get pop-ups, folks. Like I just brought up my VMware. It said, hey, we've got an update or a new version. Let's not update or any new versions for class because I really don't want to troubleshoot when someone says, well, it was working and then I upgraded it. Okay. Really don't want to do that. I try to keep folks on the same version for class. Now you can see I've done this before because I've still got my other versions for the, you know, for the company. But, you know, here's VMware. So what are you going to do first? Create a new virtual machine. Here we go. I'm going to pull it up. It says, hey, I want typical recommended install. And see where it says installer disk? Well, I'm going to go installer disk image file. I'm going to, you know, click on it. Looks like I got a 2003 version out there, but I'm going to go basically to ACC. I'm going to click on, let's see, fall 20. And see, I've got other versions out there. I got Fedora Core, Red Hat. These are other versions of the software that we've installed for class. Okay, we're going to be installing a bunch of them. Put it under UNIX 2 for our class. And here we go. Here's the ISO image. So once again, you're going to go to this installer disk image and you're going to click on the ISO. Okay, and look at this. It says CentOS detected. Now I'm going to click on next. Okay, here it says, hey, we're going to personalize this. Give it a full name, your full name, in other words. Okay, well, I'm going to say James Wade. Okay, and then I'm going to go username. I'm going to go J Wade. And then I'm going to give it a password. I'm going to do Cisco123. Cisco123. Folks, here's the thing. If you forget, you know, and I'm going to say this password is for both user and root accounts. Okay. If you forget the password, load it again. Okay. Use a password that you know, I am not going to forget this ever. I get some students in labs that will load all of this and then they'll go, well, I can't get in, Professor Wade. And I'm like, okay, what username? Well, this is the username I used. Well, what's the password? Well, I'm not sure. You know, so there we go. Cisco123. Now, virtual machine name. Notice I've got this 3 times. I'm going to call it UNIX CentOS. I'm just giving it a unique name. Now, folks, here's another one. One of the things I don't like about Microsoft. Look at this. See where it says OneDrive, folks? OneDrive. Does everybody know what OneDrive is? Answer in there. So I've got somebody asking me, VMware asks for a license key. The license key was issued to you. It is issued when you get it from ACC's, that website link that I sent y'all. Okay. And all you have to do, if you don't remember it, is go back, log in, and go click on the, look at what I've gotten, and then pull it from there. But that's where it's at. You need to go back to the original place that you got it from, which is in the ACC link that is on Blackboard, and then relog into it and go to your profile. And if you click on your profile, it'll say, purchases that I've made. Okay. It's not on Microsoft's cloud, James. Okay. Okay. So, I'm sorry. You're saying Microsoft's cloud is OneDrive. Yeah, that's correct. Microsoft's cloud's OneDrive. And I've had students that are using OneDrive, and of course I am on this. I need to disable it. But what happens is, if you said you wanted OneDrive, what it does is it stores your stuff in the cloud. The problem is when the cloud storage fills up, you could have 100 gigs, a terabyte of free space, but you filled up the cloud. Therefore, it's not going to let you load anything anymore on your system using OneDrive. I've had folks where literally they couldn't store anything on their system because OneDrive was stopping them, even though they had plenty of free space. So what I do is I go browse and I say, okay, well, I got a D drive on my system. I do not want it. And I'm going to go, let's see, documents folder. And in there, I should have one that says virtual machines. Let's see if this is where it's at. There it is. I'm going to open this up, go to virtual machines. Okay. You'll notice, though, it says virtual machines. I want a separate directory. So I'm going to type in UNIX-CentOS. There we go. I moved the directory. Now, if you don't have OneDrive doesn't come up, you're fine. Okay. But you also have to know your disks, you have to know what your disk space is. And folks, I am going to say this. If you don't have or need more skills for basic using your system, figuring out how to manage disk space, you need to find either some online classes or take some of the other ACCs like PC management or some of the lower level classes. I have some students where they've had problems where they've asked me, well, Professor Wade, what disk space what do I clean up? Well, I can't tell you what to clean up. It's your system. Okay. Figuring out how to manipulate folders on a computer. We don't really, teach that in like Unix 2 or routers or other classes. When I say other advanced classes, okay, advanced classes, because we're expecting you're coming to the table and knowing it by the time you get to Unix 2 on moving folders around, creating folders, storing your stuff where there's enough disk space. Okay. So once again, you want to make sure you got enough disk space. And then I'm going to click on next. And then I'm just going to leave this. Here, I could tell it to store my operating system in a single file or multiple files. And here, this is the minimum disk space. Once again, you got to have the disk space. And then it'll grow it from there. Okay. And now, notice that I've got everything there, but I'm going to go click on Customize Hardware. This is where you can up it. Notice, look at this, 1 gig. Well, I don't want it 1 gig. Okay. Once again, you have to know the memory settings on your computer. How do I figure that out? Well, I will tell you that, but you should know. If you don't know these kind of things, like you get in and you're like, wow, I don't know how to do that. You need to start, write that down on a little note. I need to understand this, and then start studying, or as far as Google or, oh, well, I'm sorry you didn't learn anything from the PC management. I guess it also depends on who's teaching it. I'm sorry. Okay. But I can click on, let's see if I can get down here. Oh, here we go, right here. I can go right, click on my bar, and I can do Task Manager. And once I get to Task Manager, folks, take a look. Shows me my processes. But if I click on Performance right here, it shows me how much memory I actually have. Notice right up here, see how it says 16 gigs. I have and I upgraded my system to 16 gigs because 8 gigs was just killing me because I had so much stuff running for classes. And so I upgraded it to 16 gigs. Now, also, I've got graphs here showing me I'm using about 8 gigs right now. And that's important to know because that lets me know VMware-wise, well, how much memory can I use? Also, CPUs, the only thing I don't like about, and by the way, I can click on each one of these. Here's my CPUs and see, notice how it gives me information down here. Look, see how I have 6 cores? Well, that lets me know how many cores can I give this VMware. So you have to know your system and how much memory and CPU that you have, as well as disk space. Okay, how do I check disk space? Well, I just showed you how to check CPU and memory. See right down here, it says in use 8.8 gigs. Now, see why it says 21 gigs? Well, we're going to have, and you don't want to pay attention to that, you're going to have some swap. Okay, even Windows has swap. Okay, and so up here, I'm using 8 gigs. I got 16 gigs. So, I probably got about 7 gigs available. Okay, and it's showing me from here to here, this is the memory I have available. Now, James, you say, okay, I got 16 gigs, but the system says 4 gigs. So are you saying right here when it says memory, it doesn't say 16 by 8 or 16 by 4? And so now for disk space, and once again, CPU, I'm just looking at this fine print, shows me I have 1 socket, meaning 1 CPU socket, but it's a 6-core system, meaning I have 6 possible CPUs. Okay. Oh, really? Well, what that tells me is, well, let me ask you this, James. Do you know whether you're using Windows 10? Are you using Windows 10 or is this a, what are you using? Windows 10. So it should be 64 bits because you're limited to about 4 gigs on a 32-bit system. Assuming it's a 64-bit system, maybe, if you've only got 4 gigs, you might want to, that's to me sounds, one of the sockets is bad. You could go into the BIOS and see what the BIOS says. The BIOS will tell you what it is. But if it's only saying 4 gigs right there, 3.8 out of 4 gigs, then something's wrong with your system. Although that is strange because you usually use more than 0.2 gigs to bring up your operating system. So, you might want to investigate that. How do you investigate that? Well, bring it up in the BIOS and see what the BIOS says. Okay. Even new PCs sometimes go bad, and you never know. You may have bought a new PC and they said 16, but it doesn't have 16. Man, maybe somebody in the manufacturer has a bad chip. The BIOS is the way that you can see your configuration. Okay. So this is from the operating system perspective, folks. You can always go into your BIOS, meaning you reboot your system and you hit an escape sequence or one of the F keys. You usually I have to Google to figure out, okay, which one is it? Is it F1, F2, F3, F4? It'll usually tell you, but the time it tells you in the BIOS as it comes up and you see it, well, it's already past, you hitting the F key. So then I always have to boot it a second time, to hit the right key. Okay. Oh, Nicholas, you just hit them all. And once you get into the BIOS, there's a section in there, memory. It'll tell you how much physical memory you have in it in the BIOS. It'll also tell you the CPU and what it is. So I have plenty. I got 6 cores. I've got, 16 gigs of memory. Disk space, folks. If you're wondering about disk space, well, you can, bring up your browser, right click, and go properties. Let's do that. Hold on. I'm going to bring up a new, so I don't have to disappear with that one. I think I need to reboot my system as well. You can right click and go properties, and it'll tell you how much disk space you have. So I could right click on this and it'll come up and tell me, and click on properties. And it doesn't like mine right now. I got too much stuff opened up. Anyways, you can right click and you can get how much disk space that's on the thing. Okay. Because that's another thing that you need to know. Okay. So now that I know my system and my memory, I can go back here. I know I've got at least a couple of gigs available because it said that I had about 7 gigs. So I'm going to put this at 2 gigs. Okay. And then I'm going to go to my processors and see how it asks number of processors, number of cores per processor. I'm going to say 2 cores. I'm going to up it to 2 cores. Okay. And now the network adapter here is NAT. I'm just going to leave it there. I did in the instructions, folks. Let's go take a look at the instructions. You'll notice that, let me go all the way to the top. You'll notice, see here, I tell you, give your machine a name, set the directory of where you want to store it, click next, customize hardware, go in. See how I did network connection, bridged, okay, replicate the physical network. I've had it where with this version of VMware that this didn't seem to quite work. People were clicking on bridge. Now, what's the difference in this? Well, network address translation, meaning it's going to get an IP address that is not your network IP address, but it's still going to run NAT to get out to the internet. On the bridged right here, what this would do would be get an IP address from your wireless router, and it would be on the same subnet. And I had a few folks that did this and it didn't work. So if you go to Blackboard, you're going to see on Blackboard that what it says. Let me get out to Blackboard again. Hold on just a second. Just got to figure out which one of these is Blackboard. Nope. And I got one more chance here, right? Give me 2 seconds. I'm going to close some windows while I'm teaching. I always get too many windows opened up. Let's get rid of that one. And there it is. Notice it says, right here up at the top. See, I said for the network, instead of using bridge mode, use NAT mode. So you can just leave it in NAT mode. Okay, just leave it in NAT mode. And that's what I'm going to do. I'm going to leave it in NAT mode. Bridge mode, it would get a IP address, but I've had students where that just didn't work. And so leave it in NAT mode. Now, once I've left it in NAT mode, okay, I've modified. I'm going to close it. Now I'm ready to click on finish. Now, what does it do when it clicks on finished? Well, notice up it comes. It's going to boot off of that ISO file. Let's see if it'll boot up and how long it'll take. There it goes. Because I got a lot of stuff running on my computer, and I'm going to suck up 2 gigs and a couple cores. Now, whenever we use VMware, see how I got all these systems up? Yes or no in the chat section. Do you think that if I brought all these up, I could get them all up? What do you think? Up and running? Yes or no? Yeah, no, it would suck up all my memory and CPU. Now, folks, this is a known problem. Not sure why it does it. See how it's already starting the installation? Well, that's not what I want. Okay. I made a mistake here while I was talking to y'all. So what I'm going to do is I'm going to tell this thing to power off. There we go, power off. And I'm going to show you a trick. Now, I'm sure there's probably a few people that have dialed in and they're off doing something else right now and not watching. But this is really important. If I power on the machine, what I want to do is I want to be inside it. So I'm going to click inside here. I'm going to click and see, I just had, a person, I guess, dialed off because we just dropped down to 17. I'm going to click inside it. So right now I'm clicked inside of that session. What I don't want to do is I don't want to have my mouse out here. I want to click inside there. Why? Because if you don't, it'll just pass right through. It'll go and start the install process without basically clicking on that environment. And let's see, let me go back and make sure, because it doesn't look like, it looks like it's trying to boot off the system probably. So hold on, let me power off. And I'm going to go back and I'm going to look at the CD and the DVD. And let's go edit virtual machine settings. And so you may encounter this, folks. So I've still got the ISO, okay, using auto start ISO. And I really don't want it to use that. Let's go remove. There we go. I'm going to click OK. And if I have to go rebuild this, I will. I'm going to power it on. I'm going to move inside it. Let's give it a couple seconds. If it doesn't boot up, I'll go do it. Now, what happened? What happened was I wasn't clicked on inside it, and the thing will just auto install. Immediately it'll go boop and auto install. So I wasn't clicked on it. You want to click inside this box and make sure you're clicked on that. Otherwise, it bypasses. It goes right through. And I get a lot of students saying, well, I clicked, it just keeps passing through. And I'm like, did you click on inside it? So if I have to restart here in a minute, I will. See, it already started the install process, so it may already be out there. Let's just do that because I don't want to waste any more time here. I'm going to power off. I am going to delete this. There we go. The other thing I'm going to do to manage this, watch this. So I'm glad this happened because I do get where students get this problem, okay? And it'll pass right through it. So let's go Documents. And let's go Virtual Machines. And let's go look for, let's see, Full CentOS, UNIX CentOS, there it is. See, it's got all the files. So I'm just going to delete every single one of those. There we go. Goodbye. So now I've got my directory out there that I can reuse. Nothing in it. Oh, and by the way, if you don't put it in a subdirectory, this is what it does. Puts them all here. It'll work. It just gets messy looking. I don't like it. And so I recommend students do a file here. A directory. Put it in a directory. So here we go. Create new machine. I'm going to do next. So you get to see this twice. Let's see. Let's just double check. Browse. I'm selecting that ISO, that optical file. I'm going to click on next. I'm going to give it my name, James Wade. username J Wade, password Cisco123, Cisco123. Notice it says it's optional as well. And then here I'm going to call this, let me browse really quick. Go to my D drive because I don't want to use OneDrive because it's going to fill up your OneDrive disk space. Documents, go to virtual machines. And I'm going to go to UNIX-CentOS. Okay, click OK. That looks good. I'm going to call this UNIX-CentOS. Click Next. Click Next. Customize hardware. I'm going to give it 2 gigs. And I'm going to give it 2 cores. Click Close. I'm going to click Finish. And up it comes. I'm going to click my mouse inside it. Bang. And then what I do is I will click on it again. I'll move my mouse a little bit, move it around, click on it, click on it. I'm moving it around. See, it's booting up, but what I don't want it to do is to keep going forward. Now I'm still in, my mouse is in there, and I'm just, there it is. There's my mouse, kind of moving it a little bit around, clicking here. And now, date and time, bang. See how I stopped it from just zipping through? Because that's what happens if you're, I was talking. Normally, I would have showed you that instead of me redoing it. But you'll notice what I did to fix the problem. So here we go. Chicago, done. And you can just follow the lab here, and it just goes right through. Now, here's the biggie. I'm going to go, let's go back to the lab. Notice that comes up and it says, okay, here you go, length, date and time. And then once we do date and time, I'm going to go down and do installation. Let's see if I can get this. Let's reduce this down a little bit. So I'm going to go, I did the date and time. Now I'm going to go installation destination. Okay. And notice this is already checked. Okay. So I'm going to do done. Okay. And I'm just going to click on done. Hold on. Cancel and return to custom partitioning. Give me 2 seconds. I don't want to do custom partitioning. Let me move this over a little bit. Okay. Usually what I do is I click on this, deselect it, click on it again, and then I go done. And here's the custom partitioning. I'm going to do done. And then I'm going to do accept changes. Looks like they modified a little bit since the last time I was doing it. Now, here's the important one, folks. Software selection. Remember I said click on server with GUI. Once again, we're going to go down over here. Let's go look at the lab. Looks like I need to take some different pictures. See how I said click on this? But in the past, you just click on this and it goes through. It doesn't come up and ask you. So, and then I say network and host name. Okay. Well, we're going to do, I skipped a little bit in order. Apologize for that. But I'm going to go down and we're going to click on the software we need to install right here. See software selection. Doesn't really matter what order. Okay. And so I'm going to click on server with GUI. And what does it say? KDE, DNS, and performance. So server with GUI. And then here I want to do DNS. I want to do KDE. You can just leave the Java platform. I don't care. The network, leave the others. And the other one was performance tools right there. That's what you're going to click on. You can leave the others, no problem. Server with GUI, and then performance, click on that, click on KDE, and click on DNS, and then done. Okay. And notice, give it a couple of seconds. Notice it says software installation. And then what it does is it's kind of figuring out, well, where do I want to install it? Oh, I want to install it on here. Now let's go look at network and host name and click on that. Now, what we're doing, see, it's already on, which is fine. And notice I have an IP address. That is what you're looking for. If you don't have an IP address here, folks, you'll notice that I had you click on off and on in the instructions. Well, because we're using NAT, it just does it immediately. So here we go. Let's go back. You'll notice here I say, before, if you use bridge mode, it would be off and you had to click on, okay? And what you're looking for is an IP address. Once you see an IP address, well, you are good. Click done. Okay? Security policy was the other thing. Notice no more security policies. Okay? Looks like you can research it, but once again, they're changing a little bit the install process. And I guess I'm going to have to go back and update the installation, of this lab, because before, when you went to the security policies, let me go back. Here was the security policies. So don't worry about it. Okay? Don't worry about it. I guess maybe this semester I'm going to go in here and update this, and I'll probably have it out there by Monday. Okay. Okay. So we have done our software selection. We have done our date and time selection. Pretty much really all we had to do was go over to the software selection. That's it. Okay. Because most of the rest was all done. So now I'm going to click on begin installation. And notice down below here, it shows me, oh, I'm installing software. And then it says set a root password. So here we go. It says root password is set. Why? Because it's using that root password of that account I created, Cisco123. If I want to create another user, I could create another user here. Okay. So here we go. User creation. And maybe I'll do a Joe Smith. Okay. And notice, see how it puts it on. And I'm going to make this one an administrator account. I'll give it a password of Cisco123 and Cisco123. Okay. And then I'm going to click done. So now I've got a secondary account created. And now I just wait, folks. The install has begun. Okay, looks like I had some stuff. Lisa says they all take up their own designated RAM. Yeah, usually when you do an ISO, actually you can go in and do some template configuration. But I assume that's what you mean, Lisa, is that a lot of, if they've already done a VMware and you're downloading that, like GNS3 VM, for those of you that have done GNS3, see I have a VM here. And see also I have Kali Linux. Well, they give you the VMware files. And then you just click on the config and it loads it in. Here we're building from scratch. Okay. And by default, it usually just does 1 gig of memory and 1 CPU, 1 core. Okay. But other devices, like for example, if I gave you all my VMware files after we did this, when you load it, it would come up with the configuration that I just set it, because it's stored in the VMware files. It's stored in that in those directories. So if you look, here's where we're loading it to, and you see this file that says VMX right here. Let's open this up a little bit. See, it says virtual machine configuration. Well, that is going to have the changes that I did when I changed the amount of memory and CPU. Okay. Can I change the defaults for the unintended install? No, I'm not sure why, because it's not supposed to. It's supposed to stop. I'm not sure why it just goes on. I could probably Google it, but you know, I noticed this from day one since I've taught this class that sometimes if you don't click in the window, it'll just go zip right past it. So, I mean, it'll just keep on going. See, we're still loading software, folks. It'll just keep going past it. Now, Fedora Core doesn't do that. It's only with CentOS. It's only CentOS that does it. So, yeah, I've noticed that too, Nicholas. VirtualBox doesn't do it either. It's just CentOS and VMware for some reason. So, and by the way, I don't use VirtualBox. I when I was teaching at St. Edward's, I used VirtualBox for all my classes. Why? Because St. Edward's, where I was teaching, they did not have a 1-year free license to VMware. And the reason I use VMware in our class is because that's what all companies use. They run VMware farms. And so if you can tell them, hey, I've worked with VMware before, the VMware workstation, you know, that ups you. Also, I don't know if you noticed, actually, while this is loading, let's go take a look. Let's go back to Blackboard. So on Blackboard under software, you will notice VMware for ACC. So one of y'all asked, well, where do I get the license key? Well, you go back to this site, you click on it. I'm signing in, and you should be able to sign in because everybody, this is where you get it. Okay. And what you do is you will notice that up here under my Hello James, it says my account orders. So I go to my account orders, and here's all the stuff that I've ordered. And I'll pick something. What is this? No, I'm not using 11 Pro really. I don't like showing this a lot of times because I don't want people to see my keys. But I go view details, and there's my serial number. This is what you use. So you click on the same thing. You click on your username. You click on account orders. You then find the order, which will be here. You do view details. And when you do a view details, it shows you the serial number. This is what you use for your VMware. Okay, that's the license key right there. They just call it a serial number. I don't know why VMware says enter the license key, and you're like, okay, well, this is a serial number. Why then does this call it a serial number? But it's the same thing. Okay. Now, what I wanted to show you was there's other items. Okay, hold on. Let's go to home. Look at this, folks. So here's VMware Workstation 16. Here's VMware Fusion for Apple. But look at this. See the vCenter stuff here? VMware vSphere, vCenter. Folks, this is for centralized management. You could set up your own VMware farm and play around with your own VMware. Now, do you need more than one computer? Yeah, you do kind of need one more computer. But you could go to Discount Electronics, probably pay 50 or $100 for some little server, or you could find someone that's throwing theirs out, and you could basically, what it is you load a client onto one of them, and then the one of them becomes your, VMware vCenter, and you centrally manage VMware. This is what companies use. This is corporate software that costs thousands and thousands of dollars that you're getting use of for free for a while. Okay, that's pretty cool. Okay, it is pretty cool that you have access to this. And so that's why I use VMware, because most companies do, folks. And it's nice you're using VirtualBox, but companies really don't use VirtualBox. Folks that don't want to pay for VMware, you know, like students and stuff use VirtualBox, and I've used that before as well. $100 to $200, yeah. I don't know if you can. I mean, I don't know if you can get it for Linux Mint or not. Yeah, Nicholas says you can get cheap one-use servers on Craigslist. I've actually got a couple of servers myself because I've done the same thing, folks. When you know, I don't do it as much now anymore. Actually, I'm playing. I think I've told you I'm playing with here. Give me 2 seconds. How we doing? We still loading here? Yeah, see, it's still loading, folks. So you can kind of see how long it loads. 2 seconds. You want a Unix server, folks? Here you go. Raspberry Pi. You know, this thing is, you know, pretty small. Look at that. You know, Raspberry Pi. I've got like 4 of them back here that I'm playing around with and working on building a Raspberry Pi cluster. As I get more money, I'm going to put more into it. So I'm just kind of playing around with Raspberry Pi. There's a few projects out there that are pretty cool. This is called a Canna Kit. It's a company that gives you a case. I mean, when you look at the size of this thing, you know, I mean, and this is a full-fledged Unix server. It's got a USB ports on it. It's got Ethernet. It's wireless. Okay. Um, so, and Goodwill, Seth, yeah, Goodwill as well has a place. I've been over there a few times. I've had students come back in my routers classes and switches and bring in a router that was the exact router that we have. And I'm like, how much did you pay for that? And they're like $30. And I'm like, $30, you know? We're actually getting some new equipment here in the next semester or so that you know, has been approved. So here we go. It's still installing. So, you know, Nicholas, I want to put together a app server, database server, and a Windows server on the thing. I also play around with, oh, I haven't in a while, but I have played around with automating trading, automated trading. And so I want to turn them into maybe an automated trading cluster as well. So, and I have a 3D printer over here that I 3D print stuff. You know, like, oh, if I've shown this or not, you know, like, you know, robots from Lost in Space. This was 3D printed on my 3D printer. So, you know, I printed this. I just don't have the globe for the top, you know, which is what I was waiting on. And I want to, I was trying to use a clear, but it wasn't quite working with my 3D printer. This needs to be clear. And I wanted to, you know, I've left this off because what I want to do is put some electronics in there and have it where it really indeed, you know, has a voice, you know. So, you know, it's fun. I'm still a geek. You know, I don't work in the commercial world anymore. Okay, well, every once in a while somebody calls me and asks me to do something. And then of course here we go. So my next stage is to I want to play around with props and make them real. You know, in other words, this is 3D printed phaser from Star Trek, but it's a solid piece. And really, what I want to do is get it where, you know, the button works and you know, but I don't want toys. I want like where it's a real, like you could use it for a movie prop. Okay, so here we go. Look. So what do you turn in on this? Well, let's take a look. You know, if you go down, you know, it installs it. And then I tell you, um, you know, log into the system. But what I'm really and then see, once completed, log into Firefox and Google. So folks, I want two screenshots, this one, and then I'm going to log into this. Here we go. Cisco 123. And then the biggest test is, do we have internet access? So there we go. I've created my environment, but really what I want to show is applications, Firefox. So I want two screenshots, one with your name. So when it comes to how do you want to install this, enter your name. So then the name comes up on that login screen. Log into it. And look at this. I'm already on the internet, folks. I don't want to see CentOS. I want you to go to a page of your choosing. Okay, an appropriate page. Okay, let's go to, I don't know, google.com. That's a little boring, but pick something else besides Google. Or, I mean, here's Facebook. So I have access to the internet and I'm on a system. And then you can also explore. For example, how do you open up a session and be able to log into it? Let's look. Utilities. I could go to utilities and get disk information. I could go to system tools and basically, look at this. Here's a K console. I could pull up a console here. See what happens. See if I get a login. And I'm logged in to a system, just like you logged in to do your scripts. An alias, ls minus al. I'm in my home directory. I could go /. Let's try and get a root account. I'm going to do an su minus. Ask me for a password. Let's like Cisco 123. And I'm in. I'm now root. Show me it. You could do a couple of shots. But show me that you got internet access. I mean, and you can pull up a console. Look at that ifconfig. Here's the IP address right here. 192. Let's try something else. Let's pull up. Let's do some other fun stuff while we're here. We're almost done with class. I ran past, didn't I? I'm sorry, folks. Here, let me do a putty. And just out of curiosity, let's go to 192.168.96.1, what is that, 132? Let's see out of curiosity if I can pull up a putty session. I don't know if SSHD is running. Doesn't look like it, or it would have come up immediately. And it is running. But remember, we also have firewall filters. So, and we're gonna set that. We have another lab with the 96.132. Is that what I entered? Oh, there it is. I'm sorry. It was on my other screen way at the top. I don't know why it defaulted up there. Log in as J Wade, Cisco 123. See if it'll let me log in. And there we are, folks. Woo! I'm running a putty session from my PC and connecting up to my UNIX CentOS system. Okay. What do you have to turn in on the lab? Screenshot showing your name and a screenshot showing you can go to a website on the internet. Okay. So I've got my own CentOS environment. I can log into it and putty into it. I could set, and as we move through class, we're going to set this up as a web server. We're going to access the web server software here from an external browser. And by the way, some of the labs we're not going to do a GUI, folks. That's the way it works in the real world. We don't have GUIs all the time. Okay. Desktops use GUIs, Linux desktop environments. Okay. Any questions? Yeah, Nicholas, that's a good question. I mean, if you go, look, if we go edit, virtual network editor, our VMware system, see, our VMware has two interfaces. a VMnet 8 and a VMnet 1. And notice the subnet address is 192.168.96.0. That's where we get our IP addresses from. Okay? We'll see you later, Easton. Folks, the class is pretty much done now. I apologize for going over a little bit today. Any questions on the lab, on this lab? Answer no in the chat session or feel free to ask a question. Okay, well, that's it, folks, for class today. Hope you enjoyed it. This is kind of, we're getting into the fun stuff now because you're going to get VMware and you're going to load CentOS. And as we move forward in class for the next, month and a half left of class, don't forget you got that midterm due by next Saturday. But we're now just going to install different Unix type systems. And really, these labs are built on stuff I've had to do. One of the things I've had to do is create a Unix system for me to use or someone else to use in a company. We're going to load web servers. We're going to load database servers. We're actually going to enter data into a database. We're going to do a print server. We're going to set up a Java development environment, a PHP development environment. And we're going to do some security with the filters and stuff. Okay? So everybody have a wonderful weekend, and we will see you next week, okay? Obviously, if you have any problems with getting this lab going, ask a question in the forums, or you can send me an email, okay? Chad, I don't know what you mean by your VM had issues. VM is a virtual machine, okay? Erase from C drive and reload it. So if you're having problems with VMware itself and working on your system, we do have a lab technician that can help you get that working. He's not going to help you load like I showed today and do VMware, but it'll help you get VMware working. Unless you sent that email earlier, because I usually answer emails. So I would have given you a suggestion. Okay, and did you do the suggestion yet? I'm not sure what you mean by answers. Let me go look at your email. Okay, so yeah, okay. So take a look at what I'm showing you. So when you reload VMware, all of this will be gone. Okay, all of this will be gone. And so all you have to do is, what will be there is your virtual machines directory is going to be there. So you have to figure out on your system, if you did the C drive and you loaded it on the C drive, well, it would be on the C drive under documents under virtual machines. But you're looking for that virtual machine directory. And what you'll find is you'll find either everything's loaded like I did here, that everything's under here. But what you're going to look for is those VMX files. See where it says VMX? And by the way, if it doesn't say VMX, you have to go View, and you got to click on this file name extension. Notice how it's gone now. You have to click on the file name extension. You have to go View, and then click on file name extension. What you're looking for is these VMX files. So if you see everything's under the same directory, if it looks like this, then you look for the VMX files, okay? And all you do is double click on those VMX files, and then they'll appear back in your VMware. So take a look at this. If I go to Red Hat, and I double click on this VMX file, it will then appear in my VMware. And so all you have to do is basically go through and find your virtual machine directory where all these files are at. And then you can just click on the VMX and they'll reappear in VMware. Okay? That's all you do. So if you reloaded it, yeah, I don't like that either. I wish it would go out and scan or something and, you know, actually scan and repopulate it, but it doesn't. It is kind of annoying. I've reloaded this, you know, multiple times to show students how to get VMware working, and then everything clears out. And the way that you get it back is, like I said, you go find your virtual machine directory, you know, the old one or, you know, the new one. Sometimes it uses the same directory. Okay. I think also you can go, hold on a second. You can go here and click on open a virtual machine and then go look for, and it should open it, but it doesn't look like it's doing it on mine. But you can go, basically, if I go to documents, go to my virtual machines directory, you'll notice, see how it lists them. And now look, it only shows me the VMX files. So you can click on open a virtual machine and then go find that virtual machine directory. Should be under, hold on, let's go look under my C documents. Yeah, it's going to be under your document folder under virtual machines, and see how I've got these VMX files. If I go to these directories that it put it in, there's a VMX. It only shows the VMX file. So once again, just click on open a virtual machine, go to your C drive, documents folder, virtual machines folder, and you should see either a bunch of VMX files or you should see some directories. Okay? And then you'll have all of your old ones. Any other questions? Nicholas, I show that you're still out there. You got any questions? Okay. Well, have a good one, both of y'all, and we will see you next class. I am going to stop the recording.